All right, welcome to Intermediate Algebra Final Exam Version B review. So this exam, if you are following along or you want to print it out in our Canvas course that is online math resources that you can self-enroll into. Obviously, you would know that because you're here now.
Sir,
What's up, Omar?
I can hear your voice.
Can you guys hear me now? Can anyone else not hear me?
I can hear you.
I don't know. Omar, some of the other ones can hear me. Is it not coming in for you? Or is that better? Anybody else? Jada, Catherine, Nick, can you guys not hear me?
No, I can hear you.
Okay.
I can hear you.
Okay.
I can hear you.
Omar, can you hear me now? Try logging out, Omar, and logging back in. All right. Well, let's continue. Omar, hopefully you'll log back out, log back in. Hopefully that sound will come through. So in our online math resources course, we have our own little page, Intermediate Algebra. And if you open up the Intermediate Algebra, we are under the test review material, which is right over here in the top left. Click on that. Because you are a My Math Lab, make sure that you are on the My Math Lab tab. So these are all for previous different platform. We are on the My Math Lab piece. So make sure you are on the My Math Lab tab, and the exams that we are working on, all of them are here. And right down here is the version B that we are working on. Okay, so you can open it up. The solution guide we are building as we go through right now. And the video we are recording as we go through right now. So without further ado, let's start talking about the final exam. Pardon. So, and as soon as this video is done, the solutions and the video, once we get the link to the video, will be uploaded. So there you go. And away we go. So the final exam, if you're taking it through My Math Lab, we know is a total of 30 questions. It goes all the way from the beginning of the year through what you guys were doing with quadratics. And it pretty much goes in order, okay? So we're gonna start with compound inequalities and we're gonna move all the way through to the quadratics. So we don't try and mix things up, we keep it in order. So this first one, we've got a compound inequality, negative 2x less than negative 8, and, which is important to us, x minus 4 less than 6. So we want to solve this. And it says our answer needs to be in interval notation. So that's important. All right, so let's talk about how we solve this. First off, what does it mean to be an and? What do those pictures look like? Does an and sorry, go on.
Oh,
sorry.
No, you're good.
As
What's
I
an
was-
and look like?
Yeah, and is like in like a union when it comes
Mhm.
to
Not a
circle,
union.
and
It's
it
not a
is
union.
like an open circle.
They could be open circles. They don't have to be. But
They
ands, remember, ands normally shade in the middle.
intersect basically.
Yes, the intersection. Good, Danielle. Ands is all about the intersection. Where is their overlap? And remember, with and answers, most of the time, they're brackets or parentheses with your smallest number, comma, your largest number, and then again, a bracket or parenthesis. So remember, ands are like it's bouncing back and forth between those two. Most and answers look like this, but remember, there is that 5% where they do something else. Okay. Also, if we were, so this is what interval notation looks like. Interval notation. If you were doing set notation, because I like to review that, set notation looks like squiggles, your variable, a straight line, and then it's your smallest number, less than, or equal to, our variable, less than, or equal to, the large number, and then a squiggles. So interval notation, set notation. Our answers are going to be in interval notation, but I am going to review set. I think it's important because when you move on to college algebra, you need to know how to do both of these. All right. So when we do compound inequalities, we solve these separately. So how do we solve negative 2x less than negative 8? How do we get x by itself?
Yeah, yes, Professor. We should divide 2 on both sides by
Not just a
negative,
2, but a
but a negative 2.
yes.
Negative 2 on both sides. So you have x equals positive 4. And it's going to be the same thing with,
Hold on.
yeah,
Hold on. So we divide by negative 2 on both sides, but it's not an equal sign in here.
Doesn't it like
Yeah.
the thing move? Like doesn't
it will
Keep going.
be greater.
Yes, the thing moves, the thing switches directions because remember, whenever we divide or multiply by a negative number, whenever that denominator is negative, the inequality sign must flip.
Okay.
So let's just make a quick note of that. Let's remember, whenever you multiply or divide by a negative number, the inequality sign flips, changes direction. Super important. Okay, let's graph this real quick. Well, actually, no, sorry. I'm trying to get ahead of myself. Let's solve the second guy. So x minus 4 less than 6. How do we solve that?
We actually add 4 on both sides.
Okay,
So we eliminate 4, and then you have x is less than 10.
perfect. Yeah, we can add or subtract all we want, and that will not change the sign. So it stays less than. But remember, when it comes to multiplying and dividing, be careful.
Okay.
All right, so now let's get to the graph. So what number goes down here? What's our smallest number up there?
4,
Who's our largest?
10.
Perfect. Okay. Now let's graph. And I'm going to graph above my line so that way I can put my answer down on the line. So for the 4, dealing with the x greater than 4, is that going to be, we used to do open and closed circles. Now they are brackets or parentheses. So what is the 4 going to be, a bracket or parenthesis?
Well, I believe it's gonna be parentheses.
It is a parenthesis because there's no equal sign under, or not equal to. So no line under it is a parenthesis. If this was an equal to, then we make it a bracket. So do we shade to the left or to the right for 4 based off of this information?
Well, the 4 is actually less than x, so it's gonna be shifted to the right.
To the right because we're greater than. The arrow points the direction. So that one looks like this if we did the shading. The 10, bracket or parenthesis.
Um, it's gonna be the bracket.
Gonna be a bracket?
Parentheses. Sorry.
Because there's no equal to.
Okay.
Left or right?
It's left because the x is less than 10.
That's right. Follow the arrow. It's pointing to the left. So remember, ands are all about where there is overlap or intersection between the two. Where would both of these have an intersection?
Um,
Where is their overlap?
Anywhere from 4 to 10.
From 4 to 10. And we keep the parentheses. Good job on that. So the real graph, the real answer looks just like an and answer. So now all we have to do is write up the answer.
okay.
So let's start with set notation. So it's going to be a squiggle, X, because that was our variable,
Yes.
a straight line. So what does this part look like? Remember, it looks just like this information up there. All we gotta do is fill in.
Okay. So x is less than 10.
Give me, nope, small number,
Oh, a 4.
4.
4.
Which symbol? Less than or equal to?
No, less than.
Less than. Our variable goes in the middle. Less than or equal to?
Um, no, less than 10.
Less than 10. There's the set notation. These are always less thans or less than or equal tos. Always. So there's set. But again, we want our answer in interval notation. So what does that look like? I helped you with the set. Now you guys tell me the interval. Again, it's gonna be like,
Parentheses 4 and 10.
yes, parenthesis 4 comma 10, then what? What's here?
Parentheses.
A parenthesis. Good. So it looks just like my picture. Parenthesis 4, just missing the comma, 10 parenthesis. That's the answer that they're really after right there. Any question about number 1?
No.
All right. Question number 2 is just another compound inequality, except this time, instead of an and, we have an or. So almost the same problem. Negative 2x less than or equal to negative 8, or, which is important, because that's going to tell us kind of what our answer should look like. 5x minus 13 greater than or equal to 17. All right. So let's talk about an or real quick. Where do ors usually shade?
Away from each other.
Away from each other. Good. So they're usually on the outsides more often than not. That's because ors are all about what Omar was talking about a couple minutes ago. They're all about the union. Okay. Or in other words, what I say is we want it all. That's what ors are about. Wherever they're shading, that's an answer. We want it all. So remember that their interval notation we'll have a parenthesis. Let's see how I wrote this up a moment ago. Negative infinity to your smallest number. And then it's a bracket or parenthesis. Union, bracket or parenthesis. Your largest number, comma, infinity, parenthesis. So that's what the interval notation looked like. The set notation looks like squiggle, X, line, and then it's X less than, or equal to your small number, or X greater than, or equal to your large number. Squiggles. So set notation was always easy because all we did was take our two answers and slap the word or between them. As long as it looks like this. Again, there is that 5% chance that it does something weird. All right, so let's solve just like before. How do we solve negative 2x less than or equal to negative 8?
You do the same thing as you did for the first question.
You bet.
Basically divide -2 on both sides. But this time, we have less than or equal to. So that means it's not going to be shifted, or it's going to be shifted signs.
It is going to change signs because our denominator is negative. When that bottom's negative, you got to change your signs. So it becomes a greater than or equal to 4.
4. Okay.
Whenever that denominator is negative, if you divide by a negative number and you have an inequality sign, better flip it. All right, let's solve the other guy.
So this one, we're gonna add 13 on both sides. So 13 plus 17 will give you 30, and then you divide 5 on both sides. So that will give you 6.
Does the sign stay the same or does it flip?
Since we have a negative 13, it would be flipped.
No. Look at what you're doing here.
It's the
Look at-
same because you change it because you add it.
Okay.
Yeah, remember adding and subtracting, the sign will stay the same, but look at your bottom number here. It's positive. That means no flippy.
Okay.
Only if this bottom part right here is negative, do you flip. The last step will tell you if you flip or not. All right, so let's graph. Who's our smallest?
Our smallest is 4. Our largest is 6.
Okay. So again, I'm going to graph above my line. Bracket or parenthesis at 4?
Parentheses?
Nope.
Bracket.
Bracket.
Equal to is bracket. Yes. To the left or to the right?
The right.
To the right.
I think to the right.
Follow the arrow. Okay. Bracket or parenthesis at 6?
It's the same thing as 4.
Same thing as 4?
Yeah.
So it's a bracket. Right
Yeah.
or left? I did that backwards. Left or right? Which way?
It's right.
Where?
It's right.
To the right. Okay. So this one is doing something weird because notice I don't have anything shaded on this direction. So this is not going to be one of these answers. It's going to be one of those weird ones. Now, again, this is where you have to remember, what does or want? Or wants it all. So where does this answer start?
6.
Not at 6.
4.
Starts at the 4. Wherever there is shading, that's a part of our answer. If you started at 6, then what you're looking at is the and answer because that's where both are, right? But or say wherever there is shading. Shading starts right here. That's where we're gonna start. And we're gonna go to the right because that's where all the shading is. Does that make sense? Or say, give me it all. So the shading starts here and goes to the right. If you started at 6 and just did this, that would be an and answer because that's where they both overlap. But ors don't want just the overlap. It says wherever they're shading, they're coming. So this is the answer. We just need to write this up. So let's talk about set notation. So it's going to be squiggles. What's our variable?
So for set notation, our variables will be x,
Good.
straight
And then a
line,
line,
and then 4.
not 4.
Oh,
This is not an and answer. So this is different than what we have up here. So because all of our shading started at 4, it's going to be one of these two answers. That's what's great about ors. It's a little bit easier. One of these answers or both of these answers will be used. And in this case, it's only going to be one. It's whatever
Six.
represents the 4 part. So what
6.
does that look like?
It would be 6.
No. It's whatever the 4 answer looks like. What was the answer for the 4?
Oh, it's gonna be what, greater than or equal.
So x greater than or equal to
4.
4. It's the 4 answer.
Okay.
That's where the shading started. That's the answer I take. So there's your set notation. But again, all we want is the interval notation. So we need to write this answer out as an interval. So it's not going to have a union because there aren't two pieces. There's only one. So where does my interval start?
6.
No, it does not. Where does my interval start? This is my answer.
Okay, 4.
Starts at 4, bracket or parenthesis.
It's the bracket.
A bracket. And where does my answer go? All the way to this arrow. Who does that arrow represent?
Infinity.
Infinity. Bracket or parenthesis?
It's parentheses.
That's right. Infinities always get parentheses because you can't stop. A bracket means stop. So there's the answer for number 2. This is our or answer. It's one of those 5%ers where it does something weird. It didn't shade to the outsides. Any questions on number 2?
No.
All right, number 3, moving on. So out of compound inequalities, let's solve an absolute value. So we got the absolute value of 8 equal to the absolute value of 4x plus 15. Okay. How many answers do absolute values have?
2.
There are 2 answers. Okay. And anyone can participate along. I know Omar's doing a bang up job and so is Daniela's, but anyone else can participate along. I encourage that. So there are 2 answers. And usually when we do absolute values, you guys are really good at getting me the first equation and getting that answer. It's the second answer, the second equation that usually throws us off. We'll talk about the second equation just in a moment. But let's get this first one, the one that we're really good at. What does this first equation look like?
It looks like 8 after we break out the absolute value, we'll set up the equation as 8x minus 14 equals 4x plus 15.
You got it.
First, you gotta
Stop
drop
right there.
stuff.
Sorry, Shamice, what was that?
You get
Oh,
Chinese.
Danielle.
You gotta drop the. You always tell us to drop the.
That's right.
Absolute value.
That's all you do. To get the first equation, drop the absolutes. There's your first one. And that's what a majority of our algebra students do. We're really good at getting that first answer. It's the second one that eludes us. So let's talk about, well, no, let's go ahead and solve this one, and then we'll focus in on the second guy. So let's finish this up. So how do we solve this? How do we get x by itself? What are we going to do?
Eliminate 14, negative 14,
Okay. So how do we eliminate negative 14?
by adding negative 14 on both sides, which you add 15,
All right.
you get 29.
So 8x equals 4x plus 29. Now what are we going to do?
You start eliminating 4x and you start eliminating 4x and then you subtract it with 8.
Okay.
So
So to get rid of a positive 4x, we're going to subtract it. So 8x minus 4x is 4x equal to 29.
20,
Now what?
you divide
Okay.
both sides with 4.
So one of our answers is x equals 29 over 4. And you should go to your calculator to make sure that that doesn't reduce, and it doesn't. But that's one of our answers. That's usually the answer we're always good at getting, the first one. Because all you have to do, drop the absolute values. Let's talk about how we get the second equation. What do we do to get the second equation? How does that work?
We turn everything negative on the second equation, like 4x becomes
Yes,
negative, and then 15 becomes negative.
you got it. Basically, drop your absolute values. But on the right-hand side over here, everybody becomes the opposites. Or in our case, this time, everybody becomes negative. But it's really all about making them their opposites. So that's negative 4x minus 15. Because the opposite of a positive, as you said, is a negative. And again, you told us that the opposite of a positive was a negative. So there's the second equation. What generally happens is we forget to take the opposite of the entire side. So all we do now is solve. How do we do that? How do we get x by itself?
You can add 4x to 8x.
Perfect. Add 4x to 8x. So that gives us 12x minus 14 equal to negative 15, because the negative stays with it. Now what?
You add 14 on both
Okay.
sides.
Plus 14 plus 14. 12x equals, that will give us a negative 1. And now what?
Divide by
So
12.
Yes.
yes,
Divide by 12, divide by 12, and there's the other answer. X equals negative 1/12. When you go to put your answer in, all you're going to do is put the two numbers and a comma between them. Don't do anything else. So you'll put 29 over 4, comma, negative 1/12. Done. You just put the two numbers and a comma. Remember, absolute values have two answers. And the best part is, on this, you can always check it. Take these two numbers and plug them in and see if they equal the same thing on both sides. Take 29 over 4, plug it in, and you can check it. Take negative 1/12, plug it in, and you can check it. Any questions on number 3?
No. So we're, after we're done with the first and second equation, we set up the parentheses as -1/12, comma 29/11.
Don't put parentheses, just type the number in, because you can use that My Math Lab type. You should be able to make it look like a fraction,
Okay.
okay? This is just like any other exam that you have taken, just like your homework. All these problems, and in fact, all these problems have been taken from other exams and homework. This isn't the first time you've seen these.
Okay.
I'm not throwing anything new at you. I am reusing what you have already seen. All right, so the next guy, number 4, says, let's write an equation of a line. All right, how do we write the equation of a line? What do we got to do first? Between 2 points.
We actually use the slope intercept form, which is m equals y2 minus y1 over x2.
All right. So this is actually just the slope formula, but I like where you're going with slope intercept. That's going to be what our answer has to look like. But this is just the slope formula because you're solving for m, which, as he said, was y2 minus y1 all over x2 minus x1. Or Mr. Armstrong always likes to do y1 minus y2 all over x1 minus x2. Remember, y's are always on top of the x's. Okay? Y over x. And you have 2 points. That's where we get the x's and y's from. The first point is always the 1s. The second point is always the 2s. So all this is a plug and chug. So I'm going to go with the y2 minus the y1, but there's nothing wrong with this guy. Get the same answer. What is our y2?
y2 is 9
minus, because of the formula,
11.
and then our y1 is 11. Good. Our x2 is what?
-3 minus
Minus, because of the formula. What's our x1?
-4.
Good. So you put -4. Both of these exist. This one is because of the formula. The minus is because of the formula. The negative is because of the number. You need both. Which in the end, we know that a negative by a negative is a
Positive.
positive. So this is really -3 plus 4 on the bottom. So all we do is some quick math. What is 9 minus 11?
-2, and then -3 plus 4 is +1. So you divide -2 on 1, you get -2.
Perfect. We now know that our slope is a -2. If you want to call it -2 over 1, you can do that. There's nothing wrong with that. But normally we don't usually show the 1. All right.
Don't
So
we
we
still
have,
need, I'm sorry.
go on, Danielle.
Don't we still need to know it when we go to graph the line?
If you were graphing, yes, but we're not graphing. But yes, Danielle,
Thank you.
if you were graphing, yes, we need both numbers because these are directions. This one tells us up and down. This one tells us left and right. But we're just writing equation. So we don't need the second number on underneath if it's a 1. All right. So how do we continue to write the equation? What do we got to do now? We got our slope. We've got
We
2
have-
points.
We have the point slope intercept form,
Yes, the point slope.
which is y minus y1 equals m between parentheses x minus x1.
And now the
plug
cool thing is you pick either one of these. It doesn't matter. You can do the one that's already labeled x1, y1, or you could choose the other point. It doesn't matter which point you use as long as you pick one. Catherine, pick a point for us. You want the first point or you want to work with the second one?
you said my name?
Yeah,
Oh, okay, sorry. Can we do the second one?
yeah, absolutely. I like working with the second one because it's smaller numbers. We picked the second one, so all we gotta do is plug in. Y minus, what's our Y1 according to the second point?
Y1 is 9.
9.
Since you're working with the
Mhm.
second part,
M
and
is a
then
what?
-2.
-2. Parenthesis X minus, what is the X1 according to our point?
-3.
Perfect. And we need both. This is because of the formula. This is because of the number. And we know that two negatives by each other become what again?
Positive.
Okay. So this is really what we're working with. So what are we going to do now? I got to get this into what Omar said earlier, slope intercept, which looks like y equals mx plus b. That's what we want. So what are we going to do to this?
Distribute.
You betcha.
Yes.
So what's -2 times x?
Negative 2x.
2x.
Yes, you both got it. What's -2 times 6? Or gosh, -2 times 3
Negative
Is
6.
negative.
is Mr. Armstrong. And now what do we do?
You add 9 to
that.
both sides.
Both are so good. You love it. Y equals -2x
Positive 3.
positive 3. And there's our equation. That's all there is on number 4. The first thing you got to do, find the slope. And then you'll pick a point. And then you use point slope.
Professor,
Yes.
what I've noticed in like the first one, in the first parentheses, -4 and 11, I got the same answer as the second one that you chose to.
Yeah, that's why
Then really-
that's what I was saying a moment ago. It doesn't matter which point you use. You should get the same answer. So you chose -411. You should still get y equals -2x plus 3. It's the same thing.
Well, I have a question. Sorry.
Sorry, go on, Catherine.
Could you go back to the screen so I could see it, please?
Yes.
Thank you.
And just so you know, y is the same thing as what you see on their sheet. It says f of x equals. Y means the same thing. Remember, f of x, as I told you, is just a fancy way of saying y equals. So both of these mean the same thing. Catherine, you all good?
Yeah, thank you.
Okay. Yeah, no worries. Yeah, if you ever need to see something again, you just let me know. All right, so number 5, again, we're going to write the equation, but this time it's one of them parallel perpendicular situations.
Okay.
So remember, I kind of do a setup to this where we have some sort of line 1, a relationship, and a line 2. So what do you remember goes under line 1? What do we usually put here when I worked with this kind of problem?
No, I'm trying to find the. I mean, no. I'm sorry. We put what we already have. I think, like we put
And what is it that we already have that goes here?
the first line that we're given.
The first line that you're given, the equation. They're going to give you an
point-
equation.
well-
It's going to go right here. And as you said, the first thing we're going to do,
Is the 7y thing, right? Like 7
Uh-huh.
y.
and we're going to find the slope. That's the first thing we're going to do once we put that equation here. What goes under the relationship?
Perpendicular.
Perpendicular will go here. So it's either parallel or perpendicular, the situation that you're going to get. And you're going to have one or the other. So your guys already told me some things. So we know that our equation is 7y equals x minus 14. And Omar said our relationship is perpendicular. And what goes under line 2? What do we put there?
We actually put
Once we put it in,
There's one
like,
other piece.
once we put it in point slope, don't
We
we? Like,
will,
we put it with the other points with 4, -1. Like we use the other.
yes, the point goes here. So
You
when you set
mean,
this up, I put my equation under line 1. I put my relationship in the middle, and then I put my point here. That's the setup. So that way I have my information organized. Equation is your line 1. The relationship is either parallel or perpendicular. And then right here under line 2 goes the point. And yes, you're correct. Under this one, for the third step, we will use point slope to get the equation. So we'll use point slope to help us get to the equation.
so
All right. First
Are we
things
gonna-
first, though. Yeah,
are we
hold
gonna
on.
simplify?
We gotta find the slope first.
Okay.
That's step 1. So do I know the slope of this right now?
No,
What do we gotta do first?
gonna have to divide since it's already given that 7y is equal to
All right.
14.
And what number's in front of my X?
1.
7.
A 1. So 1 there. So remember I told you that we're gonna divide all numbers. So I don't just come over here and put a straight line and then put 7 underneath. I split it up. All the numbers get divided by 7. So we have y equals, well, that's 1/7 x, because that doesn't reduce, minus, what's 14 divided by 7?
It's -2.
Yeah. So there's the equation. What's the slope now? Because now we know the slope.
The slope is -7.
No, the slope is not -7. What's the slope of this equation?
Oh, it's 1.
But I like where you're going with that.
Okay, sorry.
It's what again?
It's 1/7.
1/7. This is where step 2 comes involved. Step 2 is use the relationship.
Since it's perpendicular, would it be -7?
Yes, because
You
it's
got it.
the reciprocal.
Yeah. So step 2 is use the relationship, use the fact that it's perpendicular to find the new slope. So because it's perpendicular, as you said, you're going to do opposite reciprocals, which means change the sign and flip it. So just as you said, our new slope that's perpendicular. And I'm going to put this in the middle. Our new slope that's perpendicular is -7, because the opposite of a positive is negative. And when you flip that, you get 7/1, which is 7. And so now, as you guys told me earlier, we're going to use the point and the slope to write the equation. Y minus y1 equals m parenthesis x minus x1. So this is your x1, that's your y1, there's your m. So y minus what?
Oh, so since y equal to y minus y1 equals m parentheses x minus x1, so you have +1
Good, because a
equals
negative by a negative, so
positive.
that would be y plus 1. And because, again, it's positive because this is because of the formula, the minus. This is because of my y1. So what was our m?
So m is -7,
Parenthesis x minus what?
x minus 4.
4, because that's our x1. So we've got this that we're really working with. Y plus 1 equals -7 parenthesis x minus 4 parenthesis. So what do we do to get this in slope intercept?
Distribute.
Good. So what is -7 times x?
-7x.
And what is -7 times -4?
28.
Positive 20.
Positive 28. Good. And then how do I get y by itself? What are we going to do?
You actually subtract 1 on both sides.
Boom goes the dynamite. And now we know the answer is y equals what?
-7x. Positive 27.
Yay, there it is. So there's our answer. Again, if it says f of x, it's the same as y. So both of these are the same answer. Any questions on number 5?
We're good.
Okay, so remember, it's kind of like a 3-step process on this one. You got to find the slope of the equation first, use the relationship, and then write the equation from point slope. Number 6. You guys are doing great. Love it. Must have had a good teacher. All right, number 6. Find me the domain. All right,
Okay,
hold
so-
on 1 second. Let me get
All
this
right.
written down. So we want to find the domain of this. So in order to find the domain, what did I tell you to assume from the very beginning?
To assume that x cannot be equal to 0.
Nope.
That the
don't-
top isn't there and just put x minus 3 equals to 0.
No. What did I tell you to assume from the very beginning? Anytime you have a function, you assume this about its domain in the very beginning.
That the denominator.
Nothing about the denominator.
Oh.
So here, there's no function. What do I tell you to assume about any function from the very beginning? Doesn't matter what it looks like right now. What did I tell you to assume about the function? That the domain is what?
Oh, domain is a real number.
Yes, there you go. From the very beginning, we assume domain is all reals. Unless we fall into two different cages cases, situations. What are those two situations? One of them I have under my hand.
That
What are they called?
domain and range.
Well, we are dealing with domain and range, but what are the two functions we have to be careful of? Because
They're-
they mess up the domain. What are they called?
Oh, the interval and interpolation.
It's not interval.
It's
One begins, well, actually, both of them begin with an R.
it's real. It's real
Nope.
numbers.
Well, that's what we're assuming the domain is. We assume the domain is all reals from -infinity to +infinity. But there are two functions that you have to be careful of. What's the name of them? It's an R function. An R function. What kind of functions are they?
It's rational function.
Rational functions. That's what we have here. And
Okay.
what's the other one?
The real function.
Not a real function.
Is it root?
Root function. There it is. A root function or radical.
Radical
Square
function.
roots, things like that. Yeah. Root functions.
Okay.
There we go. So from the very beginning, you always assume domain is all reals unless you're rational or you're a root. Okay. A radical or you look like a fraction. All right, so this looks like a fraction. This is a rational function. So we have to be careful of this because our domain is no longer all reals because the denominator messes this up. And what do we do with the denominator here to find the domain?
Okay, we set x minus 3 equal to 0.
There we go. Take the denominator, set it equal to 0. So x minus 3 equals 0 and solve.
So x equals positive 3 because you
got-
add 3 on both sides.
Perfect. Add 3 to both sides. X is equal to positive 3. Now, do we like this number?
Well, it cannot be equal to.
That's right. So that makes this answer really easy. All you're going to do is put the number in here that it cannot equal. That's it. We do not like 3 because remember, if we plug 3 in here, that creates 0 in the denominator, and that's bad because we can't divide by 0. So our domain as a set notation is x not equal to 3. X can be
Okay.
whatever it wants, but not 3. Remember, I related this to you guys in videos for those that had my class, that this is like that friend that you don't want to end up babysitting at a party. You want to go to the party, have a good time, but you can't if we invite 3 to the party because then I'm going to have to babysit them. And I don't want to do that. Also, remember that we could do this in interval notation. So this was set notation. Interval notation looked like an or answer. That's the interval notation that I just wrote up right there. From negative infinity to 3, and we jump over it. Remember, I called this a jump notation. 3 to positive infinity, because we don't want to invite the 3. Everybody else gets to come to the party, but 3. So again, this is our answer. All you have to do is put the number 3 in the blank. Any questions on number 6?
No.
Number 7. All right, so we want to identify the domain. That's the big
Wait,
thing.
can you go back? Hold on.
Yes, I can.
Sorry.
No, you're fine. Take your time, Daniel.
Wow. We are not rushing this.
Okay, thank you.
You bet.
I mean, I feel like we're really benefiting a lot.
Yeah.
It's
It's the point of these reviews. So we got f of x equals the square root of x minus 7. And we're going to want to find the domain. We'll come back to part B and C here in a moment. But let's get the domain first, because that's the important part. So this is that other function. This is the radical function. So this messes up our domain. How do we deal with the radical function? How do we find the domain?
So what we're gonna do, since this is a square root, we have to square root by setting the x minus 7 square root into parentheses and make the power root of 2, and then eliminate the square root.
You're
Then,
doing too much, Omar.
oh, okay.
You're trying to solve for x, which in a way we're going to do that, but we're not squaring both sides. How do we find the domain for a radical function?
Don't you just take everything under the radical and then make it greater than or equal to the 0?
Yes, Catherine. Yes. Take that polynomial. That's what this guy is, what I call the polynomial. And you set it greater than or equal to 0. Because remember, we do not like negative numbers under the radical. Because that creates, as you guys have found out, complex numbers. And we don't want complex numbers. We want to keep those numbers real. So all we're going to do is take x minus 7, set it greater than or equal to 0. So how do we solve?
So, okay, so we're gonna add 7 on both sides.
You got it. So x is greater than or equal to, excuse me,
Plus
7. So if we write up the domain in set notation, they don't want set notation, they want interval, but I always like to keep reviewing this because it's important. So it's squiggles, x, line, x greater than or equal to 7. That's your domain. We like these numbers. So all you really do is just put what I call the embellishments around it. That's what the set answer looks like. But we want the interval answer. So we did this before.
So
We did this like number 2. Remember
Okay.
how we had that weird answer in number 2? This is
Yes.
just like that number 2. So what does this answer look like?
So it would be parentheses negative infinity 7.
Nope. Not a negative infinity. This is greater than.
Oh, okay. So you have, like brackets,
A bracket, yes, because we're equal to
bracket 7
mhm,
infinity.
to infinity. Bracket or parenthesis for infinity.
Parentheses because it's
Parentheses.
always
There you go. There's the answer. If this was a less than or equal to, because it is possible, you would have had the negative infinity and then your number.
okay.
Okay. So there we go. That's the answer they want. Because we want from 7 on up. Because if you made a quick picture of this, this is what it looks like. 7, a bracket, shades to the right. All right, so that's part A. We found the domain. Part B, all they want you to do is fill in a table. They're going to give you some numbers to plug in. So let's write down part B. So it says we have this table of X and we got 7, 8, 16, 23.
Okay.
So all they want you to do is take the 7 and plug it in. Square root of 7 minus 7. What do you get?
0.
Which is the square root of 0. And what is the square root of 0?
Mr. So for part A, we will put that.
Mhm.
Okay.
Yeah, part A says, give me the interval. So you'd put bracket, 7, comma, infinity, parenthesis. Part B, we're filling in what we know now. All right. So again, we're just plugging in. We put the 7 in for the X, and that's 7 minus 7, which is 0. What's the square root of 0?
0.
So there's the answer for 7. And then we're going to plug in 8. 8
8
minus 7,
is 1. Square root of 1
square root of 1. And what's the answer to that?
is 1.
1. Then we're going to plug in 16. 16 minus 7 equals what?
Equals square root of 9.
Square root of 9.
And the answer would be 3.
What is the square root of 9?
3.
3. And then you're going to take the square root of 23 minus 7. Which gives us the square root of what?
16.
Which
Square root
is
4.
4. All you do for the last part is find the graph that matches basically the information we just did right there. So if I drew a quick graph for part C, all I'm going to do is graph this information. Because I'm going to graph the point 7, 0, 8, 1, 16, 3, 23, comma 4. So I'm going to make a quick graph, not a very big one. 1, 2, 3, 4. And I'm going to make my x-axis count by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. The best part about for you guys is you don't actually have to draw the graph. Yours is just multiple choice. I'm drawing a graph so that we can see what we're looking at. Okay. And this will be 6, 8, 10, 12, 14, 16, 18. So one of our points was 7, 0. So 7, 0 would be right there between the 6 and the 8. Another one was 8, 1. So there's 8, 1. And then we had 16, 3. 16 up at 3. And then we had 23, 4. Close enough. So if I connect my dots, that's what it looks like. So I need some picture that looks like this. Again, you do not have to draw the graph because it is multiple choice. So which graph do you think this one is?
It's B.
B? It is not B. This graph starts at 0.
Oh, okay. Sorry. It's
My
A.
graph starts out here. So
All right.
which graph?
I believe it's C.
C? It is not C. This graph is getting large way too fast.
Okay, so I believe it's A. That's the final
It is
answer.
A. Yeah, there are going to be two graphs that look close to each other. A and C both start at the same place, but this graph gets big way too fast. My graph, look, I'm all the way over here at 23 and I'm only up at 4. Does that make sense? Look at graph C. I'm at 16 and I'm already at 4. See how this graph is getting way big, way too fast. This one is the one that's taking its sweet time. Because at 16, I'm up here at, well, it looks like it's about 2 or so.
Remember, it looks a little bit different because he drew
Yeah.
it and it looks bigger, and then in there it looks
Yes,
smaller.
my graph does look big because I'm counting by 2s down here and I'm counting by 1s. Their graph, the x-axis is not counting by 1s. It looks like it's counting by 2s. 2, 4, 6, 8, 10, 12. Yeah, the y-axis is counting by 2s. I counted by 1s. This is more accurate though. This is way too big, too fast. Everyone okay on that one?
Yes.
So in here, you'd put 0, 1, 3, and 4. And then down here, you pick the correct graph, which should be A. All right, number 8. A word problem. Dun, dun, dun. But you've seen something like this before. And this problem is not that bad. because the big thing in this one is they give you the equations. You just got to know which one to use. Okay. So let's talk this through. So it says there are two functions that can be used to describe the percent of people 25 years and older who have completed at least high school. For both functions, f of x equals 0.49x plus 87.6, and g of x equals 0.007x squared plus 0.45x plus 87.6. X is the number of years since 2008. And Y, depending on which function you plug into, is the percent of people 25 and older completing at least high school. So it says, assume the trend continues, which is fine. Find G of 14 and tell me what it means. So G of 14, let's do that part first. Part A. What function are we going to plug into? The F or the G?
I believe it's the G because for part A is asking for G. What is the G of 14? So we have to use G of x equals 0.007
You got it.
squared plus 45x plus 87.6. Basically, just plug it in, all of that, and then we get an answer.
Omar, I love how thorough you are. You are absolutely correct.
Thank you so much. I mean, sorry for multiple interruptions.
You're
I
fine.
just, I just really want to really pass this one. So
You got this. So Omar is absolutely correct. We've got these two functions. This says G. So plug into the G function. Don't plug into anybody else. So they gave you two functions because they're trying to throw you off with the F function. We don't care about the F function. Plug into G. Okay. So 0.007 parenthesis 14 squared plus 0.45 parenthesis 14 plus 87.6. All you need to do is go to your calculator and put that in. And you can make it look just like that. 0.007 parenthesis 14 parenthesis squared plus 0.45 parenthesis 14 parenthesis plus 87.6.
we'll give you 95.272.
You got it. So this right here is what I wrote. It looks the same in my calculator. All we got to do is hit enter. And like Omar said, that's what we get. Now let's double check. Does it want us to round? Nope. This does not say round. So do not round your answer. So we get an answer of 95.272. So there's part A. 95.272. Part B is a multiple choice answer, but you're also going to have to fill in some blanks once you pick your answer. So first thing, let's talk about this 14. Don't worry about these answers yet. We'll get there. Let's talk about 14. This was X, right? What does X represent for us?
So according to the, how do you say this? According to the math problem or the word problem. So X is representing the number since 2008. So,
all right. So what Omar just said is that this number X represents years since 2008. Number of years since 2008. So if X is equal to 14, what does that mean?
So, so X of 14. Okay, that means that, so the number, the 95.272 is the number of students that have little problems with the,
No, don't talk to me about students. I want to know, what does the 14 mean? This has nothing to do with students.
oh,
X is the number of
years.
years since 2008. So what does this 14 tell us?
Oh, the 2008 plus 14, that means 2022.
You got it. So in the year 2022, because that's 14 years later. So we're talking the year 2022. What was Y about?
Uh, for Y, okay, so Y is the percentage of people 25 and older completing high school.
All right. Percentage of people 25 and older completing at least high school. So Y is about that. So we found Y to equal 95.272. So what does that mean for us?
That means that in 2022,
Don't worry about the year. Just tell me what this means as far as the Y.
okay, so
What does this 95.272 mean?
uh, it means the number of percentage of people 25 and older.
What number?
95.3
Okay, so 95.272% of what?
of people
Just people?
25 and older, my mistake, completing at least high school.
If you take these two pieces here and put them together, that's the sentence we're looking for.
Okay,
Okay.
so
I need a sentence that says, in the year such and such, this happens. What sentence is that?
okay, so I believe it's, yeah, A.
It is A.
Yes, okay.
A is going to be the sentence that completes that structure. And all you're going to do is put in the year, and then right here, the year is 2022. And then in the other blank, you're going to put the percentage you found. So you will select A because that's what that means. We just took what we were talking about and combined it together into one sentence. Does that make sense?
Yeah.
Yeah. All you had to do on this word problem was plug into an equation, kick out an answer, and then tell us what it means. Okay. Now, some of these other sentences, C is really close to this. What's the problem with C? Because I want to talk about this real quick. What's the problem with C?
For the problem of C, the
Yeah.
problem is it doesn't actually match with the word problem, because in the word problem it's telling you the percent of people 25 and older.
Yeah, that's it
But
right there.
This
We're
this will be a trick.
We're missing the at least 25 and
25.
older. That's what makes C incorrect.
Yes. Okay.
What's wrong with choice B? Why does this not work?
Because it's telling you less than the percentage. And
Yeah.
the word problem is asking just basically the number of years and the number of percentage.
Good.
People 25 older.
Up here in the word problem, it doesn't say anything about the percent being less than that or less than that percentage. It just says this percentage is this. And so because of this less than part, that's what makes that piece wrong. So that's why A is the only one that works. Make sure that the wording matches what you're talking about in the problem. All right, so that right there, 1 through 8, that was all your module 1 or your first piece of
Mister,
intermediate
I'm
algebra.
confused. So the year will be I'm really bad at word problems. So the year would be 2008 or 2022.
Well, it's 14, right?
Mm-hmm.
That was our X.
Okay.
Remember, this is the number of years since 2008. So if I tell you it's been 14 years later, are we still in 2008?
No.
No, we've gone beyond that. We are 14 years after that. That's what the 14 means. So the year is 2022.
Because you add 2008 and 14.
Yeah.
So the eternity, as you can say.
Okay. Does that make more sense?
Yes, thank you.
Yeah. Yeah. The whole thing started in 2008, but we're later than that. All right. So starting with number 9, we are picking up the second module, which is all about systems and things like that and factoring. So here we've got a system. So we got 4x plus y equals 15 and x minus 2y equals 6. If you read the directions, it says use elimination. You guys are taking this exam, right?
Yes.
Am I watching what method you use?
Elimination.
Well, it says to use
Oh
elimination.
no.
No, I'm not going to be watching what method you use. So remember, you have 3 methods to solve systems. You have graphing, you have elimination, you have substitution. Now, depending on your professor, because this is going college-wide, make sure you follow your professor's instructions. But those of you that have Mr. Armstrong, you have me, I don't care what method you use, as long as you can get to that answer. That's the point of teaching you 3 different methods. It's your choice. So this does say elimination. Elimination will be the easier method for this. But if you want to do substitution on this, knock yourself out. If you want to do graphing on this, knock yourself out. I'm not going to limit you. Okay. But if you have some other professor, check with them on what they want you to do, because I'm not going to have you turn this work into me. So I'm not going to know what method you use, nor do I care. I care about, can you solve a system? Period. All right, enough on that. So it does say elimination. Elimination is the easiest answer to use. Now, just real quick about the options. Remember from the homework that in the homework, there were 3 types of solutions. There was one solution, which meant the lines crossed each other, and there was an intersection. There was the infinite solution, which the lines laid on top of each other if you graphed it. So it looked like one line. And then there was the no solution because the lines were parallel to each other. They did not touch each other at all. So the solutions to this, your choices, this was the one solution. Choice B is the infinite solution, and choice 3 is the no solution. So remember, that was the same way it was in the homework. One solution, infinite solutions, no solutions. So let's go and let's solve this problem. Because the directions did say elimination, we're going to do elimination. Because that is the easiest method. But if you want to do substitution or graphing, knock yourself out. All right, in the elimination, remember we wanted to get rid of one variable. We want to eliminate it. How did we do that? What had to happen? What was the goal?
The goal is to use the process of elimination in order to find two values or two numbers in the end. So in order to do so, we need to multiply the least equation to the same thing, to the same equation as the first one. So we
Okay.
could be able to eliminate and do the solve the rest.
Yes. All right. So what we want to do is we want to eliminate a variable, is what Omar said. And we usually have to do that by multiplying one equation or both equations. It depends on what you do. Because we want to get the same number in front of a variable, and one of it has to be positive and one of it has to be negative. That was our goal. We want the same number in front of our variable that we're getting rid of, and one of those numbers has to be positive, one of them has to be negative. Chamise, pick a variable, and it doesn't matter which one.
X.
X. Everyone always wants to get rid of their X's. I'm not sure why, but all right. So let's get rid of X. So in order to get rid of X, I need the same number in front. What number is going to be the easiest to produce here? To be the same.
It's the 4.
It's going to be 4. So we want both of these to be a 4x. Now, one of these has to be a negative. Which one do we want to be negative? The top or the bottom? And it doesn't matter. The bottom one. Good. Yes, you got this. I love it. So the top equation already has a 4x. So it matches. So leave it alone. We're just going to rewrite the top equation because it already matches. Now the bottom one has a 1 in front. So what times 1 will give us the -4?
-4.
You bet. Both are on it. So we need to distribute through. So what's -4 times 1x? -4x. We knew that was going to happen. We set it up so that would happen. What's -4 times -2y?
8.
Yeah.
-8. It's positive 8y.
Positive 8y, because a negative times a negative is a positive. And what is -4 times a positive 6?
It's
-24.
Boom goes the dynamite. And now we're ready for elimination. You could have easily gotten rid of the y's if you multiplied the numerator by 2. If you wanted to get rid of the y's, we could have gotten rid of them by multiplying by 2. It's your choice though. We chose to get rid of our x's. So what happens when I add down with my x's? Because all we do now is add down. What happens to the x's?
The X's are going to cancel out.
Yeah, that's right. Eliminated. And what is y plus 8y?
9y.
9y, because it's really just 1 plus 8. What is 15 plus a -24?
It's actually -9.
-9.
Mm-hmm.
And then now, how do I get y by itself?
Divide 9
and gives
both
you
sides.
Yeah. And then
It gives
y
us
is
what?
-1.
-1. So we now know that our answer is something, comma, -1. because you found the Y value. How do I figure out the X value?
You actually pick one of the original equations or the modified one, and then set it, plug it in, and then set it
There
up
we go.
with the value of X.
Perfect. So
Pick the
pick one of
second.
the originals and plug in. I don't want to touch any of my modified ones just in case I accidentally made a mistake
Okay.
and the math gods are on my side. Because if I plug into something I made a mistake on, and then usually the math luck does not happen twice. Math magic doesn't happen twice in one problem, usually. So I always go back to one of the originals because I know that these are correct. So Jada, which one do you want to plug into, top or bottom? It
Top.
doesn't matter which one. Sorry, say it again, Jada.
The top.
The top one. All right. So 4x plus a -1 equals 15. Or instead of saying plus a -1, you can call that 4x minus 1 equals 15. Both of these are the same. So how do I get x by itself?
You actually add sides.
Perfect.
4x equals 16 divided by 4, and then you get 4. So
Boom. Divide by 4 and x is equal to 4. So there's the answer. So we would go out and we would select the A because there's only one answer and you found it. And you'll put parenthesis 4 comma -1 parenthesis. Select A and then put in the answer because we found one answer. Any questions on number 9?
no, Professor.
Number 10, another system. All right, so this one, we have x equals 2y plus 3 and 3x minus 6y equal to 9. And again, the directions say solve the system. I don't care what method you use, but I will tell you there is one method that is easier than all the others. What's going to be the method of choice for this one?
I think substitution.
It is substitution. Why? Yeah, why?
Because the x on the top equation is already singled out.
You bet.
Yep.
We
Mhm.
already know what x is.
Because anyway, it's already there, so you could easily plug it in.
That's
and then
right.
plug in the y in the end.
You got it. So substitution is the easiest because we already know what our variable equals. X equals 2y plus 3. We're going to take that and we're going to plug it in right there. It's already ready to go for substitution. But do not get me wrong. If you want to graph, you want to do elimination, by all means, knock yourself out. I'm not going to stop you because I'm not going to be watching you. So we plug in. All we got to do now is solve for y. So we distribute. What's 3 times 2y?
6y.
Y,
What's 3 times 3?
9.
9.
And then we got a minus 6y equal to 9. Now what?
You actually have to get you have to eliminate 9 on both sides.
No, we don't.
You
We
eliminate
don't have to
65.
touch the 9.
You can group the two 6s together because they're both y's.
Yes, combine like terms first. What's going to happen to my y's?
0.
They're going to cancel out.
They're gone.
Equals 0.
They're gone. And we get 9 equal to 9. Or if you did move the 9 over, if you did that first before combining the like terms, you'd have 0 equals 0. So what does this mean when you have a number equal to a number and they're the same? What kind of answer was that?
It's actually like infinity.
This is the
Or-
infinity solution.
Okay.
Infinite.
Yay, eternity.
This is an infinite solution. So remember, when you have a number equal to a number and they're the same, it's infinite. Don't forget though, if you have a number equal to a number and they're different, what kind of answer was that?
If it would be a one no solution.
This is the no solution. So don't forget that either. But this one is the infinite. So if I came out here, which answer is the infinite? A, B, or C?
It's actually B.
B. So you would select B on this and do nothing else, because that is the infinite solution. All right, number 11, another word problem, but not crazy. I promise you, it's not too crazy. So this is a system word problem. So it says a woman bought some large frames for $17 each and some small frames for $7 each at a closeout sale. If she bought 22 frames for $224, how many did she buy of each type? So remember when we talked about systems, I said there were two versions of a word problem you're going to run into. There was a translation where I'm giving you math words and you got to translate them back into symbols, or I'm giving you standard form because it was nothing but totals. Which one do you have here? Is it a translation or is it standard form where I gave you nothing but totals?
Well, if you have a small frame, then you should. Okay, can you explain?
I just want first, I want to know what I'm dealing with. Am I giving you mathematical words or am I giving you totals? Which one did I give you?
Okay, so the total is.
I gave you totals.
Yeah.
That's
so
it.
The total.
So we are not using mathematical symbols. This is not a translation. This is pure totals. So I gave you two totals. What were they?
17.
17 is not a total.
22, 24.
22 is a total.
Oh, okay.
And who else is a total?
124.
The 224. So I am giving you standard form here because you have two totals. And remember, standard form looks like AX plus BY equals C, where C is the totals. What was the number 20, well, actually the 224 about? What was this about?
It was just the total number for large.
Total
frames.
of what?
Large frames.
Mm-mm.
Oh, total.
What was this number 224 about? What's it dealing with?
Oh, it's dealing with the total.
Total what?
The total of the both small and large frames.
Total of what though?
Okay, if she bought 22 frames for 220.
Don't worry about that. What is the 224 about? I'll give you a hint. It's the symbol that's right above, right in front of it.
Oh,
What is that
okay.
symbol?
Dollars.
Dollars. This is about money. Anything we do with this number better be about money. Does that make sense?
Okay.
What was the 22 about?
It's another dollar.
No, 22 is not about dollars. Look at it. There's no money symbol in front of it. What is the 22 about?
It's about the frames.
It's about the frames. Okay. So these are about the objects. This is about the money. Is there any questions so far about what we're looking at? So the first thing we established is that this is standard form and it has to look like this kind of equation. There have to be two variables and maybe some numbers associated with them, and they equal the totals. This total is about frames. This total is about money. Anything I put with this better be about frames. Anything I put with this better be about money.
Okay.
So the easiest one to do first is the money equation. What does the money equation look like?
The money equation would be, yeah, okay, so. Alright, since the total will be x plus y.
Not x plus y. That's going to be someone else.
Okay,
Talk to me about money.
alright, so 17 x.
17x. Let's use something other than x. Let's use labels that will let me know which frame is which.
Okay, so $17, that's for large frames.
Okay, so let's call that 17L for large.
And 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 that would be plus. Okay, so plus 7.
7.
Oh, 7 for small frames.
So give me a variable. 7.
Y.
Y. Let's use something more specific for the frames. 7.
S.
S. There we go. There are our equations. I'm going to change these up. Well, there's the first equation. 17L plus 7S equals 224. And again, this makes sense. The 17 was all about money. There was a dollar symbol in front of it. The 7 was all about money. There was a dollar symbol in front of it. This was all about money. This is what I call the money equation. Money, money, money. Now, there's a problem. Notice we used all the numbers. I used the 17. I used the 7. I used the 22. I've used the 224. There are no more numbers. What's this last equation look like then? What's that last equation look like? I've used all the numbers. You're not going to use them again. What's the last one? What's this?
It's L plus S.
You got it. Because L is about the number of frames. For large, S is about the number of small frames. So this is all about large frames plus small frames equal all of my frames. See, frames, 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 money, money, money. The equations must make sense. Now we have our two equations. All we have to do is solve it. But before we solve, are there any questions about where these two equations came from?
These two equations came from the math problem.
Well, that's true. Yes, Omar. They came from the problem. But are there any questions about where they came from? Like how I got those?
No.
Everyone else okay?
Yes.
Okay. All right. So let's solve. What method would you all like? Let's hear from Nick. Are you with us or are you ghosting me? He's ghosting me.
Nick, can you hear us?
All right. Oh, oh, nope, there's someone that wants to be admitted, but maybe might be talking in the chat. Nope. All right. So Nick's ghosting me. Catherine, what method would you like to use for this? Substitution, elimination, graphing?
Um, elimination?
Sure.
It'd be
Let's
hard.
do it. No, but elimination, substitution, they're gonna probably take about the same amount of work. But I
Okay.
think elimination would probably be a little bit easier. So
Okay.
let's do elimination.
Cool.
Yeah, both substitution and elimination are good ones for this one. Doesn't matter which one you pick. All right, so Jada, which variable do you want to get rid of? The L or the S?
The L.
Sure, that's fine. So I need to get the same number in front. What's going to be the easiest number to turn the L into?
Is 17.
You bet. It's going to be easy to make it 17. So 17, 17. Which one should be the positive or negative one? Well, actually, which one should be negative? Let's just do that. The top or the bottom?
Top.
Yeah, the top.
Yeah. Let's make the top the negative because this one already matches. Right down at the bottom. Already matches. So since the bottom one already matches, I'm just going to write it down. The top one, what do I have to multiply this by? What times the number 1 will give us negative 17?
Negative 17.
Boom. So we're going to distribute that through. So we already know negative 17 times 1 is negative 17L. We knew that was going to happen because we made it happen that way. What's negative 17 times S?
Negative 17S.
Yes. And what is negative 17 times 22?
Negative 17 times 22.
Yes,
Negative.
indeedy.
Negative 374.
Negative 374.
Yes, 374.
I trust you all with your mathematical skills. So the L's go away. Negative 17S and 7S become a negative 10S. And then negative 374 plus 224 give us what? I know it's going to be negative.
Okay, it's gonna be negative 150.
Okay. And how do we solve for S?
Divide both sides by negative 10. It will
Boom.
give you 15. Positive 15.
There we go. So S is equal to 15. And because it's S, that means we now know that we have 15 small frames. This is why I like to use variables that describe it instead of X and Y, because I know S is all about the small. So there's one of our answers. Now, how do I get the large frames? What are we going to do with this 15?
We actually gonna plug in with the either the old equation
Mhm.
or the new one
All
that's
right.
been modified. It depends
Be-
on everyone.
Yeah, you can plug into the modified. I always go back to the originals. So Barbara, you just joined us. Would you like to plug into the top equation or the bottom equation? Top or bottom, you decide.
The top.
Let's plug into the top. I like it because it's much easier to work with L plus S equals 22, smaller numbers. So it's L plus 15 equals 22 because we knew S was 15. So how do I get L by itself?
Minus 15 on both sides.
Yay. And L equals,
Okay, 22 minus 15, that would be 7.
and now we know the rest of our answer. She bought 15 small frames and 7 large frames for surezies. Any questions about word problem?
No, thank you.
Question 11, there it all is in all of its glory. I promise you on the final, it should look like a standard form type problem. All we're gonna do is change the numbers. You got this. Any questions on number 11?
Nope.
All right, number 12 is taking us into long division.
Oh,
Long division. So we got x squared plus 6x plus 8 divided by x plus 2. So x squared, let me write this down.
do you actually put the long one, which is x squared plus 6x plus 8?
So
put in a
this is
square
gonna
root.
be my question. What goes under the division symbol?
It goes under the
X.
division sign, is x squared plus 6x plus 8.
Okay, so the first parenthesis is what goes under here. Usually it's the long guy that goes under the division symbol.
Do it first.
And then the second parenthesis is what goes out front. Any questions about the setup?
No.
All right, so now we perform the long division. And remember, long division is always 3 steps. Here's who we're trying to get rid of. And everything is going to be based around what the leader out here is doing. So we need to answer this question. What times x, my leader outside, will give us the x squared on the inside? So what times x gives us x squared?
X.
X. So there's question number 1. What times the x will give us x squared? And that's x. And then remember, we take this answer and we multiply through the beginning. So what is x times x?
X squared.
And we knew that was going to happen. What is x times 2?
X times 2 is 2x.
And then the last thing we're going to do is subtract down. Now, remember, I told you 2 ways to do this. You can think of this as subtracting down, or you can turn this into a plus and make all these the opposites and just add down. So again, we can just subtract down the way it is, or turn this into a plus, but make all these the opposites. It's your call. I treat it as subtracting down. So the x squareds are going to go away. We made it happen that way. And what I have here is 6x minus 2x. So what is 6x minus 2x?
4x.
Minus 2x is 4x.
Perfect. 4x. And then the plus 8 comes trickling down like Tetris. Da, na, 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 na. And there it is. And now we repeat the process. Do it again. But this time our aim is set on 4x. Any questions before we do the 4x about what just happened here?
I have a question.
Yes.
We should be eliminating x squared and x squared, right?
Yes. You always want to eliminate the first term. So now that we eliminated that guy, we have a new obstacle. Our new term is 4x, and we want to take it out.
So it's
All
gonna
right.
be, oh,
So hold on, Shamise. So our new question is what times x equals 4x? So Shamise, go on.
that would be +4.
You bet. A positive 4 will give us the 4x. And you do want the plus. You got to show me that. So now we'll take 4 times x plus 2. So what is 4 times x?
4x.
And we knew that was going to happen. And what is 4 times 2?
4 times 2 is 8.
And then we're going to subtract down. What's going to happen to the 4x?
It's eliminating.
It's eliminated. And then we have 8 minus 8. What's going to happen to that?
Cancel out.
And that's going to cancel out. That's going to be 0. So this is the answer. That's it. X plus 4. If you were left with something here, then that would be the remainder. So if I had a 5 here, I would have plus 5 over the x plus 2. So if you got a remainder here, other than 0, you would put a plus and then that number over x plus 2. Any questions on the long division for number 12? See, it's the same 3 questions. What times my leader gets me my variable I want to get rid of? Do some distributing, subtract down. It's the same 3 steps over and over again. Any questions on 12?
So I want to know what is the, how do you actually, like answer that on Math Excel?
So in Math Excel, you will go out there and you will type in this blank x plus 4. That's all you'll do. Just like what you did in your homework. You'd have a blank there and you type in the answer you got. Okay.
Okay, so can you show me, like how do you answer it?
Unfortunately, I
like-
can't because this is not in, I'm not in my math lab. But all you would do is click in the box and you would hit your X button. Then you'd hit the plus button and then you'd put the 4.
Okay,
Done.
all right.
You would like just hit the buttons on your keyboard.
Okay, thank you.
Yeah.
So my final answer would be x plus 2 over x plus 4.
No, your final answer is X plus 4.
That's it?
That's it. Your final answer is X plus 4 to that
Okay.
guy. You would only put it over the X plus 2 if that was a remainder, but we didn't have a remainder. Our answer was X plus 4. So remember, just to show you. So let's say we had all this. Let me do this real quick. So we had blah, 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 and we did all this and we did all this. And all of a sudden, in the end, I had -3. So my answer up here would be X plus 4 plus -3 over X plus 2. All of that would get put into that square.
So
Okay. Only the
plus-
remainder gets slapped over the beginning.
okay, so why is 3 over x plus 2?
Because that's a remainder and I can't get rid of that.
Okay,
I'm just saying this is a hypothetical. This wasn't what we really did.
oh, okay,
Okay. So if you have a remainder, this is what it would look like. And technically, they would probably want you to write it like this. bring the negative in front and make it a minus 3 over x plus 2. Both of these are technically correct. They just put the minus or the negative in front. All right. Number 13. And this will end the second module. So from question 9 through question 13, this is module 2. Systems, long division, and a factoring problem. So we have r cubed plus 216. So remember, this is a cubic function. Remember with cubic factoring that you had two formulas to know: the sum of cubes and the difference of cubes. The sum of cubes looks like this: a cubed plus b cubed equals a plus b in parentheses, and then another parenthesis, a squared minus ab plus b squared. The difference of cubes looked pretty much identical to that answer. But of course, we got a minus in front this time. So the only difference was that this plus is now a minus, and that minus now turns into a plus. That's the only difference between these two factored forms, is where you put the plus and where you put the minus. When you're working with sums, the plus comes first, the minus comes second. When you're working with differences, the minus comes first, the plus comes second.
Okay.
So the question is, for this one, which form are we using? Are we doing the sum or are we doing the difference?
We're doing the sum.
Because it is a plus.
Yes.
That's how we know. So we're going to use this. Because it's a plus, that's why we're going to do this. Now, remember, in order to factor this, you need to take the cube root of the first term, and you're going to take the cube root of the second term. And these will tell you the A and the B. Who is the first term?
First term is r.
The r cubed.
Yes.
So what is the cube root of r cubed?
Is r.
It's just r. So this is A. Wherever there's an A over here, we're going to put r. What's the second term?
The second term is 216. After
What is-
square root,
What is the cube root of 216?
6.
This is B. Wherever there's a B over here, I'm going to put 6. So all we have to do is now plug in. So the first thing says that it is A plus B. So what does my first parenthesis look like?
So it would be r plus 6.
All right, stop right there. There's my first parenthesis because A is R and B is 6. Now my second parenthesis, as we start to go through it, what's the first term?
The first term is r squared.
R squared, because you plug into this, and R to the power of 2 is R squared. And then it's a what symbol?
Negative 6r.
Yes. The next one is A times B. So R times 6 is 6R. What's the next symbol?
Is b squared, which is 6 squared equals 36. Yeah,
There we
awesome.
go. Because 6 to the power of 2 is 36. And there's your answer. That is what goes in the blank. It is a formula. All you have to do is plug into it once you know what A and B are. Any questions on number 13?
No.
And that wraps up module 2. Okay, module 3, here we go. Module 3, remember this was all about rationals and radicals in that order. So number 14, we've got 1 over x minus 6 minus 27 minus 3x. All of that over x minus 6, x plus 3. So they want us to do the subtraction. In order to add and subtract rationals, what do you have to have?
The least common denominator.
The least common denominator. We need an LCD. They have to have matching denominators.
-6 and positive. I don't know. X -6 and X positive 3.
You got it. Because my little trick is I write down my denominators. I've got x minus 6, and I've got an x minus 6 and an x plus 3. Whenever I first write my LCD, I write down the first denominator, which is x minus 6. And then I see if it covers the next guy. Well, the x minus 6 covers the x minus 6, but I'm missing an x plus 3. So I got to add the x plus 3 on. And this covers both of these. There's the x minus 6 that covers the first one. And both of these cover the second guy. So that's our LCD. That is the common denominator both of these need.
We can simplify 27 minus 3x, right?
We'll get to that. Don't do anything with that yet. Okay. Yeah, do not factor this yet, even though you are correct, that can factor. Not yet. So here's what I have, the x minus 6. Here's what I need. What's missing? Here's what I have. Here's what I need.
Oh, you're actually missing. You have 1, so you wanna actually have the same numbers, the same fractions, not fractions, but same factoring as the denominator.
Okay, so what's missing up here? Here's what I got. Here's what I need.
X plus 3.
Yes, x plus 3, x plus 3. The top and the bottom is getting multiplied by that. So the 1 is just going to multiply the x plus 3. What's 1 times x?
This is X.
And what's 1 times 3?
3.
Okay. Now, here's what I've got. Here's what I need. Hey, wait a minute. They match. So do I need to do anything up here?
You actually subtract.
Well, we'll get to that, but I'm just curious. Do I need to manipulate this fraction any?
Well, you have to. Well, if it doesn't need,
It's the
because
same.
they're already the same.
It's the same. So since it's the same, don't touch the numerator. You just write it down. Since these two match, we don't have to do like what we did over here with the first fraction. Now we're going to subtract. And what I tell you about minus, subtracting, and the second fraction. What did I tell you to do with this minus and this second piece here?
You actually have to change it to plus.
Yes. We're gonna change the minus to a plus. And what does that do to my second fraction? What's that gonna do
Um,
here?
all right. So x.
We change the minus to a plus, and what do we do to this?
Oh, we actually
No
factored this
factor.
one.
No factoring yet.
Okay.
We change the minus to a plus, and what does this minus do to all that?
Oh, turns into
Change
this.
the signs.
Changes the signs. There we go. So a positive 27 becomes a negative 27. A negative 3x becomes a positive 3x. The minus changes all those signs. It's very important that you remember that. And now, what are we going to do?
Then you solve.
Define solve for me, Shamice.
You would take x plus 3 plus
Mhm.
3x negative minus 27.
Good. So we want to combine these together, put like terms together, make it one fraction. So I've got an x. Anybody over here getting together with the x?
3x.
Got
3x.
it.
Mhm.
So what is x and 3x give me?
Oh, it's 4x.
Okay. I've got a 3, a positive 3 to be specific. Anybody getting together with the positive 3?
Negative 27.
So what is 3 minus 27?
It's
Negative
negative 24.
Perfect. Now is where you will factor. You cannot factor until you get to this point for the numerator. Because if you factored this, then you just have to remultiply it back out. Trying to save you some work. So does this numerator factor?
Yes.
Yes.
What are we going to do to it then?
You take out the 4.
Mhm.
It'll
So
be
we're going to x what?
minus 6.
And that's all over x minus 6, x plus 3. And now what's going to happen?
We
You
gotta
eliminate
Who eliminates?
X.
the x.
The x minus 6's go away.
You gotta answer. Whoop, whoop.
And that's the answer. Whoop, whoop. I love it.
Yeah.
There it is. 4 over x plus 3.
Yippee.
All right. So be careful here. No factoring with addition and subtraction until the end when it is 1. Number 15. Halfway there. But
Wow.
again, we're showing a lot of work, so that's okay. So we got x over 4 minus 1 over x. All of that over 1 minus 2x. So we want to simplify the complex fraction. How do we simplify complex fractions?
LCD.
We need the LCD. We're going to clear the fractions. Let's get rid of all these fractions and let's make it one giant fraction. So we need that LCD. So again, my denominators are 4 and an x. So what's the LCD going to be?
Okay, so we have 4 and x. Is it actually x squared?
Yeah, 4x. Let the LCD be 4x. It needs to be made up of both of these.
Okay.
So remember when I talked about this, this is like playing Oprah. Everyone gets a 4x, you get a 4x, and you get a 4x, and you get a 4x, and you get a 4x. Everyone gets a 4x. What's going to happen between the 4x and the 4 here?
Okay, it cancels out. But
The 4 cancels
4.
out.
Yeah,
So what's x times x?
x squared.
So we know we got an x squared. What's going to happen between the x and the 4x?
X and 4x. Oh, the x cancels out.
X goes away. So we have 1 times 4.
Wait, yeah, there is a negative.
Yep. So it becomes -4 or
Oh, okay.
-4. Is there any canceling that's going to happen between these two?
Well, on the right side, you
Well, I
actually
don't want the
cancel
right
x.
side. I want the left side. Is there
The
any
left
canceling
side?
here?
No.
No. So what's 4x times 1?
4x.
Okay. And then what's going to happen between the x and the 4x here?
Oh, cancels out.
Cancels out. So minus, what's 2 times 4?
8.
All right, so that's the first part. We have officially cleared the fraction. Now what do we do?
Do we simplify?
Yes, we want to simplify. How do we do that?
Since we have x squared minus 4, that means we have that we factor it as
X
Good.
minus 2.
square root. X,
Yes, I heard
yeah,
it. Daniele's x minus 2, x
X
plus
plus
2,
2.
because that is a difference of squares. Yes, we got to do some factoring. What about the denominator? Anything there?
Yeah, we could do 4 times x minus 2.
Perfect. So we factored everybody to allow us to simplify what's going away.
X minus 2, I believe.
Yes. And
So-
so our final answer is what?
X plus 2 over 4. Yippee!
There it is. X plus 2 over 4. Do not try and reduce the 2 and the 4, because remember, this is a family. Because of that adding and subtracting there, if you want to take the 2 out, you got to take the x with it. So because this one is not x plus 2 down here, this is just a 4, you cannot reduce those two. So don't touch it. Leave it alone. Number 16, we're going to do some solving. So we want to figure out what is z. So we got 9 over z plus 1/2 equals 7 over z. How do we solve for z? What are we going to do?
LCD.
LCD again.
Oh,
So just like before on number 15, we're going to clear the fraction. Our denominators are a z and a 2. So what's the LCD?
So you have z, 2z.
2z. There we go. It's got to be made up of both. And we play Oprah. You get a 2z and you get a 2z and you get a 2z
For free.
for free. That's
Without
right.
unlimited payments.
All
Rated
right.
R.
So what's going to happen between the 2z and the z?
Cancels out.
What does?
Cancels out the z. 9 times 2, 18. Ew, Wookie. Let's get
There we
another
go.
one.
What's going to happen between the 2 and the 2z?
Yay, eliminate again. 1 times 2
Who
equals 2.
eliminates?
Z.
No. Between the
Oh,
2 and the 2z.
oops,
Two.
missed it.
The 2, yes. So 1
So you
times
have
z.
z. You have a z.
And then what's going to happen between the z and the 2z?
Wow. Okay, so z eliminated.
And we
And then
get
7 times 2 equals 14.
All right.
Ooh,
Now this is much easier to solve than what we had a moment ago.
Ooh la la.
So how do I get Z by itself?
You actually subtract 18 on both sides.
Minus 18, minus 18, Z equals,
Oh my God. 18 minus 14 is 4, -4.
now you need to check these answers because we got to make sure that the denominator does not produce a 0. So if I plug in, because we need to check, that gives me 9 over -4 plus 1/2 equal to 7 over a -4. So these two spots here are where I plugged in. Does that create 0?
Um, I believe.
You believe so? Does that look like a 0?
No.
Then it does not create 0. So these are -4. No, it doesn't create 0. So this answers just fine. -4 is a-okay. If this would have came out to be 0, then we got a problem and we would throw that out. But it's not 0. They're both -4s. So that answer is a-okay in my book.
Oh, yes, sir.
All right, number 17, another word problem.
Oh, wow. Well,
All right, so this one, in my class, I talked about the form of this. Hopefully other professors have talked to you about it. But what's going on in this is this is one of those let's work together problems. And they look like this. You've got 1 over the first item. You got 1 over the second item. And then this is 1 over working together. Okay. And the item might actually be about a person, like Bob paints a room in 7 hours. Mary paints a room in 3 hours. How fast can they paint the room if they work together? So it doesn't have to be an item, but it could be a person. And usually the together part is where we put the X. So let's go and let's take a look at our problem, because this word problem is like this, I promise you. So it says, Smith Engineering is in the process of reviewing salaries of their surveyors. During this review, the company found that an experienced surveyor can survey a roadbed in 4 hours. An apprentice surveyor needs 11 hours to survey the same stretch of road. If the two work together, find how long it takes them to complete the job. So experienced guy, 4 hours. Apprentice guy, 11 hours. How long does it take to work together? So what does this look like then?
1 over 4
Plus
plus 1 over 11
equals 1 over,
x. Yes.
that's what it looks like.
Let's get
My
started.
experienced plus my apprentice equals let's work together. And you're doing the same thing we just did in number 16. I need an LCT. My denominators this time are 4, 11, and X.
44x.
Say it again.
44x.
Perfect. Oprah's all gonna give us a 44x.
Come on, Oprah, give me some.
You get 44x, and you get 44x, and you get 44x. So what's going to happen between the 44x and the 4?
Oh, so you actually divide, so 44 divided by 4 is gonna be 11.
All right, so that becomes an 11 and that 4 goes away. What are we left with?
11x.
11x.
Wow, Oprah just gave me some.
What's going to happen between the 11 and the 44x?
That's the opposite, so it would be 4x.
So the 44 gets divided by the 11 gives us 4x. So what's 1 times 4x?
1 times 4 is 4x.
All right. Equals, what's going to happen between the x and the 44x?
Cancels out. The x and the x cancels out. You get 44 by multiplying by 1.
Perfect.
Wow. Have a nice day.
So there's our new equation to solve. Much easier than when we had the 1 over 4 plus 11 or 1 over 11 equals 1 over x. 11x plus 4x equals 44. It's much easier to solve. Okay. How do we solve? What are we going to do?
So you combine 11x plus 4x,
And that gives us,
14x.
try
equals
again,
44.
11x plus 4x is not 14x.
Oh, my mistake. Sometimes we all do mistakes. So 11 plus 4, 15x.
Equal to 44.
4.
And now what?
Divide both sides on 15. So you get
And,
x equals 44 over 15.
and that
Okay.
is the answer. And it should be in, I believe we're talking hours. Yes. And it wants it as a fraction, although I think that is weird. I'm not going to go into my boss and say, hey, I worked 44 divided by 15 hours this week, or 44 15th hour this week. My boss will slap me. She'll be like, don't talk math, your math mumbo. Okay. I'm just kidding. My boss will not slap me. Although this is the answer, but it would be better if they said, oh, I worked 2.93 repeating out. That's a little bit better, 2.9 hours. Or, I mean, this isn't that much better, but
2.9 hours.
hold on, sorry. Lost my train of thought. 2 hours and 14/15 of an hour. I mean, these are all the same, but this makes more sense in terms of the problem than having it written as a fraction. But all of these are the same answer. But in my math lab, it wants the 44 over 15. Even though that answer, while exact, is not the most easiest to think of in terms of that problem, like since it's a real world problem. I'm not going to go to my boss and say I worked 44 15th hour this week, boss. That's not going to happen. Say about 3 hours, boss, is what it's going to take. Boss understands that. Any questions about number 17?
No, good.
All right, number 18, we're moving into the radical sections. So the first thing is we want to multiply these two scientific notations. How do we multiply scientific notation?
Okay, so that's 18.
How do we multiply scientific notation?
Is that 16 over the 10?
It is. Yeah, we got 5 times 10 to the 16th times 2.9 times 10 to the negative third. So how do we multiply scientific notation?
So we actually Have to add or something?
Do what again, Omar?
Do we need to actually add
We will add something. Who are we gonna add?
the 5 times 10 power of 16?
No,
Oh, the other one?
there is adding, but who are we gonna add? And it's not the 5 times the 10 to the 16th. I'm not gonna add these together.
2.5 times 10 to the power of negative 3.
You would,
No, we're not gonna add these. That just changed the whole problem.
Okay.
you would move the decimals.
Oh,
We can move the decimals, but you guys have kind of forgotten on me, and that's okay. The first thing you're gonna do is you're gonna take these two numbers right there, and you're gonna multiply them. This is a
oh,
multiplying problem, so we have to multiply
Oh.
something. So we need to take 5 times the 2.9. What do you get?
14.5.
Okay. Times 10. This is where we're gonna take the powers, and these are the ones that we add.
So,
The
10
powers you add,
okay.
the numbers in front, you will multiply. So what is 16 plus a negative 3?
It's positive 13.
Okay. Now this is where Chamis said we need to move the decimal because this has officially been multiplied. That's it. But remember, we are in scientific notation. And remember that in scientific notation, this number right here has to be between 1 and 10. Is 14.5 between 1 and 10?
I believe it's not because
So
it's
we've
already
got to take,
exceeded.
yeah, we got to take this decimal and we got to move it. Which direction? To the left or to the right?
Um, it's to the left.
To the left. So if I move it one place to the left, I've got 1.45. Is that number between 1 and 10?
Yes.
Yes. Times 10, but because we move to the left, this has affected the power. What is the power now? What happens when we move to the left?
Does it become a 12?
It does not become a 12.
14, right?
It becomes a 14. When you move to the left, add
Oh, yeah. Okay.
to the power. If you were moving to the right, then you would subtract from the power. Okay. So if you moved right, subtract to the power. So that is our answer in scientific notation. Any questions on how to multiply? The numbers get multiplied,
No.
the powers get added. And then you got to double check your answer. Make sure this number is between 1 and 10. If it's not, then as Jimmy said, we got to move the decimal.
How did you get 14?
5 times 2.9 is 14.5.
Mm,
Got to multiply these two numbers. That's where the 14 came from. Okay.
Okay.
All right. So there's 18. Number 19. So we've got y to the 1/2, parenthesis, y to the 1/2 minus y to the 2/3. They want us to multiply, or in other words, distribute. That's all we got to do. If I distribute through here, what's going to happen with the powers?
It will actually add since
They
you're
will add.
yeah, since you're multiplying.
Just like what happened up here. We were multiplying. What did I do with my powers? I added them. So I need to take 1/2 plus 1/2. And what does that get me?
Gonna give you 1, 2,
One.
4, right?
No, it's going to give me 1. 1/2 of a pizza plus 1/2 of a pizza equals a whole pizza.
Okay.
It's going to give me 1 minus, all I'm going to do is add these. Y is 2/3 plus 1/2. Let your calculator do the fraction work. What is 2/3 plus 1/2?
So you actually, so it's 3/5.
It's 3/, no, it's not 3/5.
Oh,
So I said, let your calculator do the work.
okay, so 7/6.
7/6.
Yes, that's 2/3 plus 1/2.
Okay. And there you go. That's it. You don't have to have the 1 if you don't want to. Any questions on number 19?
No.
All we had to do was distribute through, which means add the powers. Let the calculator do that fraction work. So that way we're not second guessing our answers. Because sometimes our mental math leads us astray. Sometimes, not all the time.
Others believe the opposite, professor.
I know.
Yeah, they believe something. I believe that math is causing madness. Like someone literally swear that after he finishes high school and college, he can burn the entire math books.
Some people believe math is made up by the devil.
Yeah,
Thank you for joining my cult. All right.
you're welcome.
So on this one, the directions say rationalize. Because remember, some Joe Schmo long ago said, I don't like radicals in the denominator. And because of Joe Schmo, we got to fix this. So how do we rationalize this answer? How do we rationalize to simplify?
Okay, so you multiply 3 minus -11 on both sides.
No,
On the denominator.
it's not 3 minus the square root of 11,
Oh,
but you're
okay.
close.
Oh, you multiply negative square root 11.
Nope.
Isn't it 3 plus? And then the
Yeah,
square root?
there it is. What? You got to use the conjugate. Okay. Conjugates. Remember, if you have A plus B, the conjugate is A minus B. If you have A minus B, the conjugate is A plus B. We have an A minus B. So the conjugate is 3 plus B. Or 3 plus the square roots of 11. And now we just do some multiplying. Remember, with conjugates, all you have to do is the Florida. Trademark, Mr. Armstrong. The Florida. So 3 times 3 is?
9.
9. A negative times a positive is a negative. And what is the square root of 11 times the square root of 11? The whole reason why we're doing this,
Wouldn't it just stay 11?
it would just be 11. Because when you multiply two radicals that are the same, the radical pops out. And what is 9 minus 11?
9 minus 11 is -3. It's -2.
Well, which one is it? -3 or -2?
No, -2.
Okay, there we go.
Oh, wow.
Now, in the numerator, we need to distribute through. So we will take 4 times the 3, which gives us what?
So you will get 4 times 3 is 12.
And then we're going to take 4 times the square root of 11. And what does that give us?
4 times the square root of 11. 4 square root 11.
4 square roots of 11. Because remember, the 4 and the 11 can't really multiply each other. This one's under a radical, this one's not. They don't really like each other. So, but we got to write them down. So this is what we have. The last thing you need to do is to see if this can all reduce. So is there a number that can divide 12, 4, and 2?
Yes.
What number is that?
So it's actually 2.
It's actually 2. So we can actually take and actually divide both of these by that -2. So it actually looks like 12 divided by -2 plus 4 divided by -2 with a square root of 11. What is 12 divided by -2?
12 divided by -2 is -6.
What is 4 divided by -2?
-2.
That is the final answer. Because
Oh,
both of these just get divided by the -2. 12 divided by -2, -6. 4 divided by -2, -2 with a square root of 11. There it is. Any questions on number 20?
Why wouldn't you combine the -6 and the -2?
Because this guy has a piece tacked on to it. It's very much like this. That square root of 11 is acting like a variable.
Okay.
These two don't get combined together, right? This has an X, this one doesn't. Same idea. This is like a variable. Okay. Barbara, is that good? Barbara. Okay. So there we go. Number 21, 10 more problems. We're almost done.
You mean 9?
10, because we go all the way to 30.
Yeah, we're in 21, so we have
21 all the way to 30 is 10. Trust me.
Oh, really? Oh my God.
Yeah,
Then
I know.
wonder how math is so complex.
I know. So this time we're going to solve a radical. Solve a radical.
Yippee.
Okay, here we go. So we have the square root of x plus 4 equal to the square root of 2x minus 3. So when we solve a radical, what are we going to do? How do we do that?
We take off the square roots.
We're going to take out the square roots. In other words, you need to get one square root by itself first. Luckily, we have that. This square root of x plus 4 is already by itself. So how do I get rid of a square root symbol?
By multiplying it by 2.
You're not multiplying it by 2. You are
by making it a parentheses.
squaring it. Yes.
Yeah, squaring it. Exactly.
To get rid of a radical, a square root, You got to square it. And what's cool about this is actually both sides have radicals that are isolated. So the square is just going to knock out the radicals and leave us with x plus 4 equal to 2x minus 3. And now all we got to do is solve.
Okay,
What are we going to do now?
so we should eliminate x
How do we do that? Well, it's not
by,
really eliminating. You want to get the x's on one side.
yeah, so we're just gonna have to take out the x's by subtracting x on both sides.
Okay,
The x
so we're going to move this guy. So minus 1x, because it's a positive 1, minus 1x. So that gives us 4 equal to x minus 3. And if you want to put the 1 in front of it, knock yourself out. You don't have to. There's nothing wrong with just having the 1. Now what?
Okay, so after that, we're gonna add 3 on both sides.
Woo!
Yep.
So x is equal to 7. But you are not done. Just like the
Divide.
no, we're good.
Okay.
Just like the rational problems, you have to check this answer. We have to make sure it is a-okay up here.
Okay.
Okay, so you do have to check. But we will have to make sure that we go through the entire check. So we got to see this all the way to the end to make sure both sides match. So we got 7 plus 4 equal to, or square root of 7 plus 4 equal to the square root of 2 times 7 minus 3. So 7 plus 4 is what?
So 7 plus 4 is equal to square root of 11.
All right, so we got to make sure this other side matches that. 2 times 7 is?
14 minus 3 is square root of 11.
And 14 minus 3, as you said, is the square root of 11. So this checks out. So this answer of 7 is good. So in the box, all you got to put is 7. All right, number 22. So it says the formula V equals the square root of 2GH gives the velocity in V in feet per second. So V is velocity. And that is feet per second. Just writing down some information of an object after it falls h feet. So h is kind of like its height. And that's in feet. H feet accelerated by gravity g. So g is gravity in feet per second squared. So that's feet per second squared. So all I did was just write down some information. So V is velocity in feet per second. H is height in feet. And that should be IE, not EI. And G is gravity in feet per second squared. And that was the formula they gave us. So they say that if G is approximately 32 feet per second squared, so we know G is 32 feet per second squared. Find how far an object has fallen if its velocity is 24 feet per second. So we know velocity. 24 feet per second. So another word problem, but it's not that crazy because they give us everything we need. What are we going to do with this information they told us in our equation?
Okay, first of all, you're gonna plug each the requirement, and you're gonna plug in each given into the equation that's given, which is b equals
Yeah,
square root 2gh. So v equals 24 equals
Oops,
square root 2 times 32h.
perfect. And I just wrote 32 again, and that was the number I'm trying not to write. So let's go with 24, Mr. Armstrong, equals just like what you said, Omar, 2 times 32 times h. All you had to do is plug in and then solve for h.
Okay, so this one, the next step, we're gonna have to square root it. So we're gonna
Not yet. You need to
after
square
we
these.
multiply it. Yeah,
Yeah.
after we multiply. So
What
it's
is
64.
2 times 32?
64
Okay.
h.
Now what are we gonna do?
We square root it on both
No,
sides.
it's already square rooted. How do we get rid of the square root? We what?
We multi
We don't
okay,
multiply. We what?
we raise it the power to the 2.
Raise it to the power of 2. There we go.
Yeah, that's what I'm saying. I'm trying to say the first. So forgive me.
It's okay. So what is 24 squared?
576.
And the square takes care of the square root. So that leaves us with 64h. And now what?
You divide the 64 on both sides, so the final answer is h equals 9 feet.
Perfect. H is 9 feet. That's how high the object was. It fell 9 feet. It was 9 feet off the ground. Any questions on number 22? It's a plug and chug. They give you everything you need. You just got to plug in the values and solve for what's missing.
No,
All right. And that, my friends, wraps up module 3. So module 3 was questions 14 through 23. Sorry, 22. 14 through 22 was module 3, the third unit. And now we're on the last unit, 23. Starting at number 23, this is all about the quadratics. This is all about the quadratics. So we've got this quadratic. I want you to solve. Now, again, in this quadratic unit, you learned 4 ways to do this. You could do it through graphing. You could do it through the quadratic formula. You could do it using the square root method, or you could do it during factoring. Now, all these methods have their pluses and minuses, their pros and cons. The one method that works every time is what method?
Factoring.
Factoring does not work every time.
using quadratic formula.
The quadratic formula works 100% every time. So if nothing else, when you're solving quadratics, if you choose the quadratic formula every time, you should be able to get to the answer. If you are solving, quadratic formula works every time. Okay. Now, again, remember that everything in this test has been in order the way you learned it. What was the first method you learned of solving quadratics?
That you should learn how to get these values using the quadratic formula, which is x equals negative b plus or minus square root b squared minus 4ac all over 2a.
All right, that's the quadratic formula. That was actually the third way that you learned how to solve a quadratic. What was the first way that you learned how to solve a quadratic?
You actually said you actually use the cross multiplication.
No cross multiplication. Remember, there were 4 methods that you just learned. I just said them: factoring, square roots, quadratic formula, graphing. Which
Okay.
one of those four was the first one that you learned when solving quadratics?
Is the first one just factoring?
Factoring.
Yeah.
This is a factoring problem. Okay, I guarantee you, number 23 on the exam, if your professor doesn't mix everything up, is factoring. Okay. And remember, you learned lots of ways to factor. If you're in my class, I taught you that you could do the AC method, the box method, guess and check. Well, I didn't really teach guess and check. I said, if you wanted to learn that, you can come see me. Slide and divide. You had 4 different ways that we could factor this. It was your call. I'm going to do 2 of those methods. I'm going to do AC. I'm going to do slide and divide. So let's go with Barbara. Which method do you want to use? AC or slide and divide?
AC.
You bet. So AC method starts out with, tell me the A, B, and C. And anybody can answer this. What is A? What is B? What is C?
A is 1.
B is -5.
Huh? C?
Negative.
C is- Yeah.
-14. There we go. And remember, now we play the X games where you got A times C is the top number and the B is the bottom. So A times C is 1 times -14. That's -14. Our B is -5. So remember, this is a game. We're trying to figure out these 2 numbers that are right there. And the way we figure those out is we're going to look at the factors of 14. What times what gives me 14? So we're going to look at the factors of this. So the factors of AC.
7 and 2.
7 and 2. And 1 and 14. Don't forget the easiest one of all. So these are the only ways we can get 14. So the way this works is one of these 2 factors, either through addition of positive numbers or negative numbers, because these could be positive or negative, somehow in here, there's a way that we can add them together and get -5. So through these factors, one of these factors is going to give us -5. How?
It'll be -7,
And a,
+2.
all right. So these numbers right here, remember those 2 question marks must multiply to A times C, or in other words, the top. And the 2 question marks must add to the B. Multiply to the top and add to the bottom. So -7 times 2 is -14. -7 plus 2 is -5. Check and check. And then we go to the setup. And remember, the setup looks like this. You're going to keep the first term. In the middle goes the 2 question marks with X. And then you're going to keep the last term. So first and last term stay. So X squared minus 14. In here go the 2 numbers you found. -7x plus 2x. And then from here, all we do is grouping. So what's coming out of the first parenthesis?
X.
And what's that leave us with?
X minus 7.
Okay. What's coming out of the second parenthesis?
2.
A positive 2, because it has to match. These two parentheses must match 100%. And in order to make them match, it has to be a positive 2. So what is the answer factored?
X
Um,
minus 7, X plus 2.
Perfect. So all of this right here happened through grouping. So step 1, step 2, step 3, step 4. Now that it's factored, we can solve. What do we do with these two parentheses to solve? Because I want to know what X is.
We actually have to transform the signs. So for example, x equals positive 7 and x equals negative 2.
Good.
So that would be a solution.
Yeah. We have what is called the zero product rule. And that's exactly what Omar was leading us through. The zero product rule says that if I have two numbers that multiply and give us 0, or two things that multiply to 0, then A has to be 0 or B has to be 0. So if I want to know these answers, all I'm going to do is take each parenthesis and set it equal to 0, which helps us transform our numbers, like what Omar said. We're going to add 7 to both sides. X is equal to 7. We're going to subtract 2 to both sides. X is equal to negative 2. And there's our two answers. So that was the AC method. Let me show you slide and divide just down below, because I don't need a lot of room. Slide and divide method. So with slide and divide, again, you're going to start out with your ABCs. So that's not going to change anything. It's still 1, negative 5, negative 14. Then step 2, you play the X games again. So nothing's changed. Negative 14, negative 5. And you found that the answers are negative 7 and 2. Nothing's changed. First two steps are the same. Here's the third step. You're going to make your two parentheses with X's, and all you're going to do is put in your two numbers. Minus 7 plus 2. Oh, look. It matches. So there it is factored. And then you're going to continue on with the zero product rule. So there's slide and divide. Some people like slide and divide. Some people like the AC method. That's why I show both of them. And there you go. Any questions over number 23? Okie dokie artichokes. Number 24. So this one says use square roots. So it's telling you what to do. So we got 2x minus 1 in parentheses squared equal to 9. All right. How do I use the square roots on this? What are we going to do?
Oh.
Okay, Professor, you hearing me?
I can hear everything.
Okay, so I was saying, for the question number 3, I used the cross multiplication method, which I did is,
The
like cross
question
multiply
for this one,
for 23, yeah. I cross
let's not worry.
multiply,
And I'm sure that will work. Okay,
yeah,
but I want to focus in on 24, okay?
okay, so anyway,
It's okay.
I'm okay with that. So this one, I'll tell you I'll tell you the steps. First of all, you actually cross the square rooted
Mhm. There we
or
go.
yeah, square rooted.
All right. So because the square part is by itself, that's the first thing you need to make sure that happens. Make sure the square part, whatever's in parentheses squared, is by itself. And once that happens, we take a square root of both sides because the square root will take care of the square. So we'll have 2x minus 1 equal to what?
2x minus 1 equals 9
Oh,
equals
no.
3.
No, it's not 3 either. Oh, I'm a horrible teacher because it didn't stick. It's not a positive, or it's not just 3 here.
Oh,
What is
positive
over
and
here?
negative.
Yes, there it is. Now I'm somewhat redeemed.
Okay.
Yes, when you take a square root of both sides, the square root of the number that you're looking at becomes a plus or a minus because there are 2 answers that work. All right, now we got to continue solving. What are we going to do now?
You actually add 1 on both sides.
And we get 2x equal to what?
2x equals to positive 3, that would be 4, negative 3, that would be negative 2.
Good. So I like what Omar was doing. There's another way that you can do this. I'm going to work this together. But what Omar was doing was he split this up into 2 equations. So from here, if you don't want to work with this all together like what I'm doing, you can make this 2 equations and solve them separately. One where you have a positive 3, and then one where you have a negative 3. Because that's what this really means. When you have the plus or minus here, it means you have 2 equations here. One where it's equal to the positive version, one where it's equal to the negative version. But because I'm going to work this together, I'm not going to put them together yet. But what Omar was doing was solving them separately. And we're going to get to that, Omar. So what would I do now to get x by itself?
You actually divide 2 on both sides, and you got your final answer.
All
So
right. Well,
x
hold
equals-
on.
all right.
So divide by 2 on both sides. So x is equal to 1 plus or minus 3 all over 2. And this is where we're going to get our 2 answers from. Because one of these, well, actually, one of our answers will be x, where it's 1 plus 3, and then we'll divide it by 2. And that's what this answer would have been if you solve this guy. The other answer will be 1 minus 3 divided by 2. And once we do this one, that's the answer that you would get if you solve this one. So now let's do the math. 1 plus 3, as Omar said earlier, was 4. What's 4 divided by 2?
It's 2.
So there's one of our answers. And then as Omar said earlier, 1 minus 3 is negative 2. What's negative 2 divided by 2?
Negative 1.
There we go. That's it. There's our 2 answers.
And the solution set, if it was asking in a final exam, what is the solution set?
So
You
you'll
put
come in,
negative 1 and 2.
yes, and put a comma between them.
Yes, a comma as well. That's important.
So negative 1, comma, negative 2. Actually, it's a multiple choice answer. So this
okay.
one, you would actually select D. But if it was something like number 23, you'd put 2, comma, -1, or -1, comma, 2. It's your choice on how you put it in there. Any questions on number 24?
Nope.
Number 25, we're almost done. You guys are doing great. Thank you for hanging in there. So number 25 says, use the quadratic formula. So 9m squared plus 2m equals 6. We want to solve using the quadratic formula. If you don't like the letter m, what can we change it to?
It could change it to x.
Yeah, you just change it to x. So this is the quadratic formula. Omar gave us the quadratic formula earlier. He said x equals, and again, m can be the same thing as x, the opposite of b, plus or minus square root of b squared minus 4ac all over 2a. So Omar gave that to us earlier. Now, the way I like to work the quadratic formula is I like to work it in 2 steps. Because if this does something that I don't like, technically we're done. And remember, this b squared minus 4ac is what I call the discriminant. Not discriminate, discriminant. Okay, so the first thing I deal with is the discriminant,
Oh, yeah. All right.
which is b squared minus 4ac. So in order to deal with this, I need the a, b, and c first.
Wait, I have a question. Wouldn't you
Yes.
make it equal to 0?
Thank you, Catherine. I'm glad that you caught that. Before I can get the a, b, and c, I got to set this equal to 0. Because in order to run the quadratic formula, you must equal it to 0. Must be equal to 0 to run the quadratic formula. Super important, that little note is. So what is this formula equal to 0 then here? How do we get this equal to 0? What are we going to do?
Add the 2, like 6.
No, don't add the 2.
No, like, don't you do like subtract, sorry, subtract 2m.
Don't subtract 2m. Leave that alone.
You can subtract the 6.
Subtract the 6. Move the 6
Oh,
over here.
yeah.
So you got 9m squared plus 2m minus 6 equal to 0. Now, what are the ABCs?
So
A
A is
is
1,
Uh-huh.
B
Uh.
is 2, and
Uh-huh.
C is -6.
Boom goes the dynamite. All we're going to do now is plug into the discriminant. So B was 2 minus 4 times A, which is 9, times C, which is -6. So in my calculator, remember, I do this in 3 steps. This is the first step. This is the second step. And then I will deal with the subtraction. So what is 2 squared?
2 squared is 4.
And then it's minus. And then now in my calculator, I'm going to take 4 times 9 times -6. What do you get?
Okay, so 4 times, yeah, -4 times 9 times.
Not a -4. Whoa, whoa, whoa. That's a minus. That does not get tacked on to that. That's where a lot of people have their downfall with the quadratic formula.
So -216.
You get a -216. Okay. This is a minus. Don't tack it onto the 4. Let's leave that there. So what happens with a negative by a negative? That turns into a
Positive.
plus. And what is 4 plus 216?
It's
220.
220. Now, this is why I do the discriminant first. Because when you get to college algebra, and again, remember, I'm preparing you for college algebra. Since this is positive, we're going to keep going. But if you were in college algebra, if this was negative, you would stop and be done with this problem. This is why it's important. We're prepping you for college algebra. So because this is positive, we're going to keep going. But if this was negative in college algebra, you would have stopped. Okay. So you know, if this would have turned up negative, you would have kept going regardless. In intermediate algebra, we keep going no matter what this number is. But when you get to college algebra, just so you know, food for thought. If this is negative, stop, you're done. So now we're on step 2. And this is where we're going to plug in the rest. Plug into the rest of the formula. Because we already know what this number is. So we're going to plug into the rest of this formula. So I need the opposite of B. So the opposite of a positive 2 is a negative 2. Plus or minus square root of 220, because we just did that. We did the discriminant, so I can just plug that number in. All over 2 times A. A is 9. See, the second step is much easier. There's less to work with, less to be overwhelmed by. So now it's just all about cleaning up. And again, you can call this X or M. It doesn't matter. So what's 2 times 9?
18.
Okay. So this is what my quadratic formula looks like. Now, we need to start doing some reducing here. This is why you learned all about radicals before we taught you the quadratic formula, because we need to reduce this radical down. Square root of 220. So the square root of 220. Remember that we have a property that says if I have 2 numbers being multiplied under a radical, I can separate them. This is what I call good child, bad child. Remember, the good child is the biggest perfect square that will divide that. So remember, perfect squares, that's what I abbreviate PS, are 4, 9, 16, 25, 36, and so on. So I need the biggest number in here that is a perfect square. In other words, a number that is squared, because 4 is 2 squared, 9 is 3 squared. So if you forget how to make perfect squares, that's how you do it. Take a number and square it. 16 is 4 squared. I need the biggest perfect square that divides 220. So you just start from the very beginning and start working your way through. 4 divides it. So right now, 4 is my biggest perfect square that will divide this. But I got to keep going. 220 divided by 9. Nope, that's a decimal. 220 divided by 16. Nope, that's a decimal. 220 divided by 25. Decimal. 220 divided by 36. Decimal. And you keep going. The next one is 49. Nope, that's a decimal. 220 divided by 64. Decimal. 220 divided by 81. decimal. 220 divided by 100, decimal. 220 divided by 121, decimal. 220 divided by 144, decimal. 220 divided by 169, decimal. 220 divided by 196, decimal. And I'm going to stop there because 15 squared is 225. 225 is bigger than 220. So I stop.
By 20, it gives you 11.
Whoa. We don't consider 20 a number because we're looking at perfect squares. 20 is not a perfect square. You can only consider perfect squares. So what was the biggest perfect square that divide this?
2.
No, it was not. 2 is not a perfect square. What was the biggest perfect square that I told you divided this? I read them all off. Which one was not a decimal?
4.
4. So this number looks like the square root of 4 and the square root of 55, because 55 times 4 is 220. This was the biggest perfect square in my list that divided it. And the reason why we like perfect squares is because it's a good child. Good children get to go out and play. What is the square root of 4?
2.
2. The bad child,
Root of 55.
the bad child stays indoors. So this is the radical reduced. And we're going to take this part and we're going to replace that radical to this. So after you run the quadratic formula, the first thing you need to do is reduce the radical if it can. And then, just like what we did back in the rationalized example, number 20, remember how we reduced this? We're going to do the same thing again. Is there a number that divides all of these? Is there a number that can divide 2, 2, and 18?
Yes, 2.
Yes. So what is 2 divided by 2?
1.
That's
-1.
-1. Plus or minus. What's 2 divided by 2?
1.
Square root of 15 or 55. All over what's 18 divided by 2?
9.
There's the answer. Let's see what they want us to do with this. So you will write it out using a, okay, so separating your answer. So when you write this out, you need to separate these two. So your final answer is M equals -1 plus 1 square roots of 55 over 9, comma, and then you'll have -1 minus 1 square roots of 55 over 9. That's how they want your answer written out. So in the end, once you run the quadratic formula, you need to simplify the radical and then simplify your numbers on the outside, and then separate into two answers. And that's it. You don't have to have this one there if you don't want to. So if you don't want to say plus 1 squared to 55, you don't have to have the 1 there. All right, my little whiteout is messing up on me. So the 1 that was in front of the square root, you don't have to have it there if you don't want it. This guy right there. You do need this one. Any questions on number 25? Quadratic formula works 100%, but sometimes it's a long process. All right, number 26. It's a word problem, but don't let that scare you, because all you're going to do on this word problem is run the quadratic formula. That's it. All you got to do is run the quadratic formula for number 26. They give you the equation right here. Okay. So this problem says a waterfall has a height of 1,100 feet. A pebble is thrown upward from the top of the falls with an initial velocity of 16 feet per second. The height of the pebble h in feet, so that's what height is, h is in feet, after t seconds is given by this equation. H equals negative 16t squared plus 16t plus 1,100. Again, h is the height. And it's in feet. And t is the time. And it's in seconds. Okay. So it wants to know how long after the pebble is thrown will it hit the ground? And then you got to pick a label. Okay. I don't think we had that
So,
the earlier one. Hold on.
Professor,
Yes.
does that mean that we have to plug in the equation with the number, since it's in the word problem? It's giving us the initial velocity of 16 feet per second squared.
That's what this guy is. It's already
Okay.
plugged in.
Oh, all right.
So,
So
like
that
I
means it's
said,
quadratic.
on this problem, you're going to use the quadratic formula. And again, in order to use the quadratic formula, what did I tell you? Or actually, Catherine told us this. In order to use the quadratic formula, what does it have to be equal to?
You have to set it equal to 0.
You bet. And h is in fact going to be 0. Now let me tell you why I know that.
So h, it's not actually given. It's required.
No, h is given
required
to us.
find the h.
H is given to us.
Oh,
Remember, h is the height of the pebble, right?
yes.
We want to know how long does it take for the pebble to hit the ground.
Okay.
So if I have a pebble, or I take my pencil or my pen here and I drop it and it hits the ground, how high is that pebble or my pen off the ground? I took my pen, I dropped it. How high is that off the ground? if it hit the ground?
How long?
I didn't ask how long. I said how high. Here's my pen. I dropped it. It hit the ground. So how high off the ground is it? If it
Oh.
hit the ground?
It's 11 100 feet.
No. You hit the ground. How
Oh.
high off the ground are you if you hit the ground?
Oh, it's given us in the equation.
No, you're not thinking. All of you, take your pencil or pen, whatever you got, hold it out to the side of you. I'm physically doing this. Drop it. And I want you to look at it. How high off the ground is that pencil or pen? This is not a trick question.
It's 0 because
It's
it's on the
0.
ground.
Oh, 0.
There it is. Yes. When you are on the ground, your height is 0. That's why we can get away with this. Does that make sense?
Yes.
Yes.
H is 0 because we're on the ground. That's why I want you to use the quadratic formula. It's ready to go. This problem, if you try and plug some number in, you're thinking too much. These numbers are already in the equation. You just have to say H is 0. And now let's use the quadratic formula. Now, the cool thing about this is a word problem. And look right here. It says we're going to round. We're going to round. That means we don't have to do all that crazy work we just did on number 25. We're not looking for an exact answer. We're going to look for a rounded answer. So all we have to do here is plug in to the quadratic formula and then go to our calculator and let it do its job.
Okay.
We're going to plug the whole equation into the calculator. So before we do that, what is our A?
A is
our
negative
B,
60.
and our C? Negative 16 is A. Okay, what's B?
16. And
What's
C
C?
is 1100.
Okay, 1100. So let's plug in because I want to know what my equation looks like. So the opposite of B is a negative 16 plus or minus square root of 16 squared, because that's what B was, minus 4 times our A, which is negative 16, times our C, which is 1100. Fix that because it needs to be a little bit longer. All over 2 times our A, which is negative 16. I'm going to plug all of this into my calculator right now. We do not have to go through and do everything that we did in number 25. We just need to get an answer.
So, Professor,
Yes.
I calculated the, like the discriminative rule, which is b squared minus 4ac, and I got the result of 32 square root 69.
And that's cool, but we don't even need to do that. Let's go to our calculator. Let's put in the entire equation. We don't have to do it in pieces. So let's go out here. And if we hit alpha y equals and put in our fraction, we have negative 16. We'll do plus first. Then we're going to hit second x squared to get our square root. And then parenthesis 16 parenthesis squared minus 4 parenthesis negative 16 parenthesis, parenthesis, 1,100, parenthesis, scroll down to parenthesis, -16, parenthesis. That is exactly how it looks on my piece of paper. Look, you can't even tell the difference. It's the same thing. They look the same. All we have to do now is push enter. And there's one of our answers. And it said round to the nearest 10th. How many decimal places is 10th? How many decimal places is 10th?
It's actually number 8. So you have -7.806, and then you're gonna add 6 on 0. It's gonna be 1. So -7.81. So 1 is it's not actually greater, because it could be greater if it's number from 5 to 9. So the final is -7.8, but you want a positive number, not the negative.
All right,
So
okay, hold on, Omar. Giving us a lot of information.
all right.
So, and you did too much like rounding. 10th is how many decimal places? Just answer that question.
It says number 8.
So the 10th is 1 decimal place.
Yes.
So you went all the way to the 3rd and started rounding up. Don't do that. You look at the next number. So 0. What does 0 tell the 8 to do?
To round up.
No.
Oh, to add.
0 says, hey, 8, stay the way you are. So it's -7.8. The 0 says stay. 0 to 4, leave it alone. 5 and above, round it up. Watch your rounding. So -7.8. Now that's one answer. Now I'm going to go up. I'm going to grab this and I'm going to do it again. I don't need to retype it out, but all I need to do is change the plus that's in here to a minus. This is why I love the graphing calculator. I don't have to retype that thing out. I just got to get to the plus and turn that into a minus. And now hit enter. There's the other answer. So what's the other answer?
The other answer is 8.8, where 0 is telling to the 8, stay away from it, and
not stay away, just stay.
Yeah, stay.
Stay. So we've got 2 answers now. We've got a -7.8 and an 8.8. Now, Omar, you were saying we don't want this guy. Why?
Because the answer, it should be like in positive, and that
Why?
it's asking for time. Time is not asking for a negative decimal. Instead, it's asking for positive. So 8.8, it should be the right answer.
There we go. You got to throw that out, because if you
Trash.
have if you have negative time, that means you just invented time travel. Please let me know if you do that, because I will be a silent partner and we will be filthy rich. Okay. So we throw the -7.8 out because that represents negative time going backwards about 8 seconds in time. We can't do that. So in this problem, in this situation, if we're on top of a waterfall and we throw a pebble, it's going to take about 9 seconds for it to get to the ground. And you would circle seconds because that's the label. Are there any questions about number 6? So you would put 8.8 and circle seconds. Again, number 26 is much easier for us because we don't have to be exact like what we did in number 25. We just go to our calculator with our numbers plugged in and let it kick out the answers. Any questions? Okie dokie artichokes, moving on. Number 27, I can see the finish line.
Yay, we're almost there.
We are almost there. All right, number 27. Now, this is the only one in the entire exam that you will graph. So you will have to graph on this one. So there's a couple things that are going on. So they're giving us this equation, f of x equals parenthesis x minus 4 squared plus 5. And it says sketch a graph of the quadratic function and the axis of symmetry, state the vertex, and give the equation for the axis of symmetry. All right. So I kind of do this problem a little backwards. The graphing is what I do last. The graphing is what I will do last. Let me see something here. Trying to work up my graph real quick. One, two, three, four, five. Just making a graph. That's why it's taking me a second. So I made a graph and I'm counting by ones, and I went out to 5s on the x-axis. So this is +5 down to -5. I went up to, I'm going to say 7s on the y-axis and down to a -3 on the y-axis. This is as big as a graph of what I need. Obviously on here, they're going to give you a bigger graph to work with. Okay. We'll talk about graphing in just a moment. I want to talk about these two. So I want to find the axis of symmetry and the vertex real quick. What's great about this is what we call vertex form. This is vertex form. Because this looks like the following equation. A x minus h squared plus k. Even though you do not see an A here, there is an A. It's 1. So this is in this form. This is A. This is H. This is K. When you are in vertex form, the vertex is whatever H and K are. Okay. So if I look at this, here's my H. What number is the H?
It would be +4 because
You are correct. When you do this, even though this looks like a -4, remember that this minus is because of the formula. So whenever you look at the H, whenever I think about it, I always think to myself, it's the opposite of what I see. This looks like a -4, but it really is a +4. What's the K value?
The K value is 5, but since it's actually written as positive, so it'd be -5, or it
Nope.
stays as it is.
It stays as it is. So the H, you think the opposite. The K, you're gonna keep. So think opposite here, keep. There's the vertex. Parenthesis 4, comma 5, parenthesis, because it is a point. Now, the axis of symmetry, this is an equation. That's going to be x equals. The axis of symmetry is what I call AOS. And it is always
AOS, axis of symmetry.
axis of symmetry. That's right. And it is always x equals a number. And in fact, you already know what this number is.
It's 4.
That number is whatever h is, which, as Omar said, it is 4. So this is why I do B and C first, because I already know them. I know what they look like. I know what they are. It's giving me everything right here. So in here, you're going to put, for part B, parenthesis 4, comma 5, parenthesis. For part C, you'll write x equals 4 because it's an equation. You have to have the x. Now, all we have to do is graph. So here's a couple things that you can do to help yourself out. So here's the real way that they want you to think about this. The original graph looks like this. This is what the original graph of x squared looks like. All that has happened to this is that this graph has been picked up and moved to the left and right or up and down. Remember that H moves you up and down. Sorry, left and right. Almost messed that up. Oh my gosh. H moves you left and right. Okay. If your H, if it looks like a negative H, you're going to move to the right. If it looks like a plus H, you're going to move to the left. This is how it looks. My H looks negative. So I'm going to move to the right. So we need to move right 4. All these points are going to move to the right 4.
Professor?
Yes.
So how did he be able to set up this vertex?
How would we be able to set up the vertex?
Yeah, how did you actually put it on 0 instead of 4?
Hold on, I'll get to that. So let me talk about H and K first, and then we'll talk about this part. K is the one that moves you up and down. So if it looks like a minus K, you're going to move down. If it looks like a plus K, you're going to move up. So this looks like a plus K. So that means we need to move up 5. So going back to what Omar was saying, this is the original graph. This is not the answer. This is the original graph. The original graph always starts at the vertex, or sorry, starts at the origin. And then all we're going to do is move these points to the right 4 and up 5. So this, the vertex, that explains why it's at 4, 5. Because if I move to the right 4, 1, 2, 3, 4, and up 5, 1, 2, 3, 4, 5, that's the vertex. All these other points are going to move that direction. 1, 2, 3, 4, 1, 2, 3, 4, 5. And this point will go 1, 2, 3, 4, 1, 2, 3, 4, 5. And these points will move to the right 4 and up 5, and to the right 4 and up 5. This guy is the real graph. That's the answer right here. Now, when you do this in my math lab, remember that the moment you click on this graph, you're going to get a toolbar down here. And it's going to have, I think the clear button is over here. It's been a while since I've looked at that toolbar. It's like clear. And then you've got like a dot, a line tool, the quadratic tool. There might even be a circle. And then there's also like a solid and a dotted. I can't quite remember the layout of the tool. I'm sorry. It's been a while since I looked at the graphing on my math lab. Okay. So when you want to graph this quadratic, you're going to come down here. You're going to click on the quadratic. And remember, you're going to do 2 dots. The first dot you plot is the vertex. So you go to 4, 5, and you click. So after you click the tool, you go to 4, 5 and click. The moment you start moving around, the quadratic shows up. The second click needs to be one of these points. So the second click, this is 4, 5. The second click should be 5, 6 or 3, 6, because that's where those points are at. So I click the tool. My first click is 4, 5. I move out here. My second click is 5, 6, and there it is. Now, these directions also said we want the axis of symmetry, and it's a dashed line. The axis of symmetry is a vertical line. So you click the dash, or actually click the line tool, click the dash, come up and click on the vertex. And then I would come down here and click on X at 4, and that will make a dashed vertical line. That's X equals 4. This is my function of f of X equals X minus 4 squared plus 5. It needs the quadratic and the dashed line. It needs both of those. To show you what it looks like graphically, this is what it should look like. X minus 4 squared plus 5. Give me a second. I'm gonna have to turn something on. This is just so I could graph it, so I can show you what it looks like. That's what it should look like on your graphing screen. And this straight up blue line should be dotted. That line right there should be dotted. Actually, I can even make it dotted. Go up into this. This is what it should look like. Oh, really? You would do that, wouldn't you? So I thought I could make it dotted, but I can't. So, but again, it should look like this. That is the quadratic, and that is the blue line. So again, this is our graph right here. That's what it should look like for part A. Here's the answer for part B. Here's the answer for part C. Now, let me show you a shortcut. That's the way it really does work. Let me show you a shortcut. If you cannot remember that this is just transformations, like that's what Omar was struggling with. Omar was like, where did this come from? That's because this is all about transformations. Here's another way to do this problem. Go to your graphing calculator. Go out and actually plug this in. Plug in that equation and hit graph. I taught you, and hopefully other professors taught you, how to find the vertex of this graph. Go to second, calculate. Right here, this is a minimum. Remember, minimums look like U's. Maximums look like arches. This is a minimum. Scroll down to minimum. And it's going to ask you 3 questions. It says B to the left. So let me scroll to the left. So I know my vertex is right here somewhere. So I'm on the left side of it. I'm going to hit enter. So I'm telling my calculator, don't go past this on the left side. Now it says B to the right of it. So I'm going to scroll past the vertex. And I'm to the right of it. Hit enter. Now I said to my calculator, that's why you see these triangles. I'm telling my calculator, between these 2 triangles is a vertex. Find it. That's the 3rd piece. Now I'm going to guess. So I'm going to scroll over to my vertex and I'm going to hit enter. Boom, it has found my vertex. So if you can't remember anything that we just talked about at all for this problem, go to your graphing calculator and graph it. And on the graph, you can have it find the vertex for you. As I just showed you. Second, calculate. If the graph looks like a U, use the minimum. If your graph looks like an arch, use the maximum. So again, it looks like it is a U, so it's a minimum. So I'm going to be to the left. Enter. I'm going to be to the right. Enter. And then I'm going to guess. Enter. And there it is. Whenever you have 0.9999999, they want you to round that. So 0.9 rounded up is 4. So the vertex is 4, 5. Now you're like, well, Mr. Armstrong, in here, in order to use this, I got to have 2 points. Where do I get the second point? Go to the table. Second graph. Here is a table of values. If you scroll down, look. There's your vertex. 4, 5. How do I know that's the vertex? Because this is the only Y value that I don't see repeated on my screen. Look around it. 6, 6, 9, 9, 14, 14, 21, 21, 30, 30. This is the only Y value that's repeated. Or sorry, that is not repeated. Everybody around it, these are points you can use as the second plot. So here's the vertex. Here's another point. Use those to your advantage. Plot the vertex and then plot one of these other 2 points. So I would select the quadratic. I would plot the vertex 4, 5. And then I would pick one of these other points. Oh, 3, 6. So I plot the vertex and then I plot 3, 6. There's my graph. Don't forget that you need the axis of symmetry. All the axis of symmetry is a vertical line through the vertex. So grab the line tool, grab the dash, click on the vertex, and then click directly below it on the x-axis. And there's the vertical line. So if you can't remember anything I just said about transformations, all this stuff right here, have the calculator help you out. Because it'll give you everything you need to know. It'll tell you the vertex. And it'll tell you a point that you can use. I know that's a lot. There was a lot in this problem. Are there any questions over number 27?
No, that helps. That second part helps.
Yeah.
'Cause I was struggling on graphing with the homework.
Sure. If you forget all about the transformations, then have the calculator do the heavy lifting. Graph it in the calculator and let it do its job and kick out information for you. All right. Number 28. So they're giving us an equation, f of x equals negative 4x squared minus 8x minus 7. They want to know what is the vertex. Well, this isn't as easy as the number 27 one, where it was basically telling us the vertex from the very beginning. We got to do a little bit of work. So down here, I also showed you, and your professors have shown you, another way to find the vertex when you are in standard form. Remember, standard form is ax squared plus bx plus c. Or y equals, I should say, or f of x, same thing. So in order to find the vertex, the first thing you're going to do is find the AOS. Because if you didn't notice from the previous problem, the axis of symmetry is a part of the vertex. And there's a formula for this. The formula for the axis of symmetry is x equals the opposite of b all over 2a. It's like a part of it's a part of that quadratic formula. So all we need to know is what's b and what's a. What is the b up here? Actually, what is the a?
-4.
What is the b?
B is
Negative.
positive 8.
No,
Mhm.
b is -8. Negative. Careful. All we got to do now is plug in. X equals,
All right.
what's the opposite of a -8?
It's positive 8.
Positive 8. And 2 times -4.
-8.
Oh, 8, negative 8. So 8 divided by 8 is -1.
So now we know for the vertex that the x value is -1. Because that's what the axis of symmetry tells us. It tells us the x value. How do you find a y value if you know what x is?
You can plug the x into the original equation.
You got it. That's it. We're going to evaluate f of -1. We're going to plug it in. All we got to do is plug in and let the calculator kick out our answer.
All right.
So what do we get
Negative
for our
3.
answer? Say it again.
-3.
-3.
Yeah. So if you multiply -4 times -1 squared.
Whoa, 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 whoa. Okay. Oh, you can't multiply first. You got to square it, right? I always
Yeah.
want to make sure that we're clear on that. So we got to square this first, which gives you a +1. +1 times a -4 gives us -4. What's a -1 times a -8?
-1 times -8 is positive 8.
Okay. And then -7. And that's how we get the -3.
Yeah. Okay.
I knew where you were going, but I didn't want to confuse everybody because when you said take the -4 times -1 squared, you can't multiply first. You got to take care of the power first.
Okay. So
And
anyway,
then multiply.
anyway, my apologies, guys. So
It's okay. I just want to be clear on that. But if you go into the calculator and you put this in the way you see it, the calculator will take care of all that for you. So there you go. There's the vertex. That's it. That's all they wanted. So in the blank, you'll put parenthesis, -1, comma, -3. Or if you forgot how to do that, you could go to your calculator and graph it. -4x squared -8x. I got to delete that square out of there. Hold on. Make sure that that's gone. -7. There's what it looks like. And you can see -1, -3. But you should double check that, just like what I showed you. Second calculate. And is this one a maximum or a minimum?
Maximum.
You're gonna choose the maximum. You got it. 'Cause it
Maximum.
looks like an arch. When it looks like an arch, it's a maximum. So we want to be to the left. So we scroll past. Enter. We want to be to the right. Scroll past. Enter. And then take a guess. Scroll up. Enter. And there it is. Now, if you get the 0.00000, just knock those off. -1, -3, which is what we got. So you could use your calculator to help you out. So if you ever end up with 0.9s, round it up. If you end up with 0.0s, knock them off. And again, you could also find the vertex from the table. So if you hit second graph, looking at the table, scroll up and down. Oh, look, there's only one Y value that doesn't repeat right here. That's your vertex. Any questions on number 28? So if you forget how to do the math, there's a way that you can help get through it.
You said you got 3. How again? I'm sorry.
Our vertex is -1, comma -3. Is that what you're asking about, Daniele?
Yes, because I just plugged it in. I'm just trying to figure out what I did wrong.
So let's take, so when you plug in, does it look like this? You hit -4, parenthesis, -1, parenthesis, squared. Then it is -8, parenthesis, -1, parenthesis, -7. You need to make sure that this is a minus and a minus. See, there's a difference between a minus and a negative. If it looks like this, you get the -3. Watch your minuses and negatives when you plug it into the calculator. There is a difference between those. See, minus, oops. Let me put something in here. Negative and a minus. See the difference between those two? That's a negative symbol. That's a minus. And the calculator knows the difference. Okay. Any other questions on number 28?
No.
29 and then 30. Oh, so close. I know. Thank you for bearing with
Oh my
me.
God. Thank Mother of God, nature.
I know. All right. So this one is a word problem, but do not let it freak you out because this word problem is a lot like the number 26 that we did. Okay. It says if a projectile was fired straight up from the ground with an initial speed of 224 feet per second, then its height in feet after t seconds is given by the function. So we've got h of t equals -16 t squared plus 244 t. And again, h is height in feet and t is time in seconds. It says find the maximum height. Okay. We want the max height. When I taught you guys, or any other professor, if they do this, if you see the keywords max or min, what does that mean you're after?
That means you're after for
The vertex.
You're after the vertex. That's it. If you see the words max or
you're
min,
after the vertex.
that's right. Find the vertex. That's what it wants. Okay. So we want to find the vertex. Well, we know how to do that. We just did it a moment ago.
Using the axis of symmetry, which is equals to negative b over 2a.
Okay. So what is our A then?
A is negative 16. And
What is our B?
224.
Okay. So we're going to plug in. The opposite of 224 is a
Negative 224
over 2 times what?
over 2 times negative 16.
Okay. So you just go to your handy dandy calculator and you figure that out.
So the answer equals negative 7.
It's not a negative. You got negative
Oh, it's 7.
224 over negative 32, which gives us
Sorry,
a positive
7.
7. Yep. All right. So that's X. That would be actually, instead of calling it X, in this case, our X is really T. So that means this would be 7 seconds. Is that what we're after? Seconds?
Yes.
No, we're not after the time. What are we after?
We're after for the maximum height.
We're after the height. So we're not going to stop here. But you do now know that it takes 7 seconds to reach the height.
Yes.
How do we find the height? What are we going to do with the 7?
We should plug number 7 on the function, which is h of t equals negative 16
You got it.
t squared plus 224t, and then you should get the results.
There we are. All you got to do is plug it in.
And
Plug it in, plug it in.
it equals 784.
So 784, because we let the calculator do it. Label. What's the height? In what?
Feet.
Feet. That's the answer thereafter with the label. The max height is 784 feet. Any questions on this one? And again, you could go to the calculator and do some stuff. So we could come in here and would say negative 16x squared plus 224x. Now, if you hit graph, something interesting is going to happen. You're just going to see a line. So you don't see the vertex. But if you go to second graph and look at the table, we can start scrolling through looking for the one Y value that does not repeat. Up. There it is. See how all the other Y values around it repeat, except for 784, because that's the vertex. Any questions over number 29?
Nope. For the last question.
This is it. We made it. Last question. Now, so you know, questions 23 through 29, those are the last module. But question number 30 jumps back into module 3. It is a complex question. So questions 23 through 29 our module 4 or the last section, but question 30 jumps back into module 3. We want to do the division. And more specifically, we want this answer written as a complex number. So we've got, hold on, we've got 9 plus 5i divided by 1 plus I. We want it written as a complex number. Our answer must look like some number plus some number with an I. Couple things. What does I mean?
I is -1.
How about the square root of
So
negative
square
1?
root of -1.
And what happens if I square the I? What is that answer?
1.
Nope,
-1.
it is a -1. So these are important facts for us. This is what the answer looks like. And these are going to be some important facts we need to use. Now, because I represents a square root, that means you have a square root in the denominator. Do we like square roots in the denominator?
No.
No. So this is a lot like that rationalizing problem. How do I get rid of this 1 plus I in the denominator? What are we going to multiply top and bottom by?
Can you do it to the power of 2, so then it'll cancel out the I?
Nope. We're not going to square it. Again, this is just like that rationalizing problem. How did we rationalize? What did we have to multiply top and bottom by? What did we use?
You're gonna have to multiply 1 plus I on both
Not
sides.
not 1 plus I.
9 plus 5i.
Not 1 plus, nope. It's not a plus. You were close with the 1 plus I, but it's not a plus.
It's minus.
Yes. You got to use the conjugate.
Oh my
Whenever
goodness.
you have addition or subtraction in a denominator with a radical, you have to use conjugates. More specifically, this is what we call the complex conjugate, because you have complex numbers. Remember, if you have A plus BI, the conjugate is A minus BI. If you have A minus BI, the conjugate is A plus BI. You have to use the complex conjugate. And again, just like before, we're going to do the Florida for the conjugate. Trademark, Mr. Armstrong. So what is 1 times 1?
Okay, so
1.
multiply 1 times
1.
1 is gonna
Good.
be 1.
Then we're going to multiply a positive times a negative. What's a positive times a negative?
Negative.
And what is I times I?
I squared.
Oh, yay! There we go.
Woo!
So, but
Yay.
we know what I squared is. What is I squared?
Oh, it's -1.
It's a -1. So 1 minus -1. And a negative by a negative becomes a positive. So what is 1 plus 1?
Oh my goodness, it's 2.
So there's our denominator now. Okay. Now for the numerator, we will have to FOIL. We're going to do it all. First, outer, inner, last. So what's 9 times 1?
9.
What is 9 times negative I?
Negative 9i.
Yep, it's just like multiplying a variable. What is 5i times 1?
5i.
And last, what is 5i times negative I?
That would that be negative 5?
Negative 5 I
I
times I?
squared.
I squared. Good.
I squared.
All
By the
right.
moon
Oh,
and the
wait a minute.
stars.
We know what I squared is.
Oh my goodness. It's negative 5 times negative 1.
Yeah, what is a negative 5 times a negative 1?
It's
I squared.
positive 5.
So we have 9 minus 9i plus 5i plus 5, because a negative 5 times a negative 1 makes a positive 5. Does that make sense?
Yes.
All right, we still got to clean up though. Who can get together with the 9?
9 and 5.
What is 9 plus 5?
9 plus 5. It's 14.
And who's going to get together with the negative 9i?
Oh, it's 5i. So it's going to be negative 4i.
Now we are almost to our answer. All we're going to do is divide both of these by the 2. Or in other words, we're going to split it up into its fractions.
So you mean
14
4 over 2.
Hold on. 14 over 2
14 over 2.
minus 4 over 2i. Do you see how this is taking the form of a plus bi? Because this is the a, this is the b. So what is 14 divided by 2?
It's 7.
Minus what is 4 divided by 2?
It's 2i.
There's the final answer. 7
Yay!
minus 2i.
Oh my goodness, we've
Any
won.
any questions on where that came from?
No, Professor.
All right, my friends. That is
Wow.
the
Talk about 30
intermediate
questions. We
algebra
talk about 30 years.
final exam.
Oh my
Are there
lord.
any questions overall?